Hey guys, welcome to my practical web development guide for 2024. So believe it or not, this is the 8th or ninth year that I've done this. I think the first one was back in 2016 or 2017. So it's crazy how fast time goes by. And I'm sure that many of you or most of you know what this is, but for those that don't, every year I do this guide and I go through just about every web development technology that I can think of, from tools to languages to frameworks, as well as some of the different routes that you can take and just offer some of my own personal advice to succeed in web development. And I do this because it's extremely overwhelming just to learn what you need to learn because there's so many different things. So I try to put it all in one place and put some things into perspective, and you can kind of pick your path from there. And I also have a page on my website that has all the content that I've created, including YouTube videos and playlists, as well as premium courses on a lot of the stuff that we talk about in this guide, and I put it in the same order as well so it's easy to follow, and I'll have a link to that in the description. All right, so a couple of notes, some things to keep in mind as you're watching or listening to this video. It is long, so you may want to kind of put it on in the background while you're cleaning or exercising or whatever it is you do, and I'll have timestamps in the description so you can just jump around if you want to. So first off, you do not have to learn everything we talk about. In fact, I'd say it's impossible to learn everything that I mentioned in this guide, even if your life was extended 100 more years. So look at it like a restaurant menu. You can see what's available, and then you pick and choose what looks good to you. So next, this is not a latest trends video. I know there's a lot of those types of videos out around this time of year. I will outline some of the new technologies, but that's not what this video is about. It's about absolutely everything that I can think of that you may have to learn as a web developer. And I don't care if it's 20 years old or 20 days old. If it's relevant, then I'll talk about it. Also, if you've watched past years, you'll notice that I don't really remove anything. I just add to it. So most of the stuff that was in last year's video will still be in this year's video. I just elaborate it on a bit differently. I don't even go back to previous years for reference. Lastly, I always try to keep these pretty objective. However, I do share my opinion on some things. I'll try to make it clear when I'm giving my opinion. Keep that in mind that neither myself or anyone else has experience with every single piece of technology in this guide, so some of it is based on research and just what I've heard from others. All right, so before we talk about specific technologies, I want to talk about some of the common roles and paths that web developers choose. And I think it's important because it will help you decide what you want or what you need to learn. So the first one is one that I feel like is overlooked a lot, especially when it comes to like YouTube videos and so on. Typically, they just talk about front end, back end, full stack, but a web designer is pretty typical path to take, which is sort of like a mix of development and design. And these are people that are more focused on the front end, but don't really build complex UIs and applications. They stick to, static websites, small business websites, things like that. They may use a CMS like WordPress. They're usually pretty good at design as well as HTML and CSS because a lot of times they go solo and they're freelancers, so they have to build their projects from the ground up. And they typically have some knowledge of programming, basic JavaScript, etc., but usually not enough to build a complex full stack application without using some kind of third-party software. So they get into kind of the business side of things, SEO, maybe some marketing, things like that. So if that sounds interesting to you, then you might take this route. Next, we have what is, I guess, the most common role that people start with, and that's a front-end developer. So this is someone that works on the client side of the web, so they work on the user interface, they create the interactions that a user has with a website or web app. Now, I will say that the lines between front-end and back-end are getting more blurred every day, especially with technologies like Next.js, where some of the page is rendered on the server and some of it's rendered on the client. But for the most part, front-end developers work on the client side of the web, with the most important technologies being HTML, CSS, and JavaScript in general. Most of the time, they'll also move on to front-end frameworks like React, Vue, Angular, and I'll talk more about those later. Next, we have a back-end developer. This is someone that works on the server side, so they work with databases, database ORMs. They're not focused on the user interface at all. They're usually the ones building the APIs that the front-end developers will consume and get data from the server. Now, with the front end, your programming language is typically going to be JavaScript, but on the back end, you have dozens of languages to choose from. You can use JavaScript, of course, with something like node.js, but you can also use Python, PHP, C#, and many, many more languages, which we'll talk about later. Then you have a full stack developer who works on both the front and back end. So you'll need to know HTML, CSS, JavaScript, but also need to know a server-side language or server-side technology. You'll work with databases and ORMs just like a back-end developer. Now, in my experience, it seems that most full-stack positions are more focused on either the front end or the back end, but you still do need to know both. And again, that line is getting more and more blurred, and it seems that full stack is the most popular end goal for people. It seems, at least from what I see, running a channel and seeing a lot of developers and people that are coming up, it seems like front end is where they want to start, but ultimately they want to be full stack developers. Now, I'm going to throw a fifth role in there, and that's DevOps. And this is someone that's responsible for deployment and maintenance of your application, maintenance of the servers, their security, scalability. They do write code, but it's not the same as front-end or back-end development. You're not building the application. You're building the infrastructure that the application runs on. And you'll typically need to know technologies like Docker and Kubernetes. You'll need to know about certain hosting platforms like AWS. You might write Bash scripts, Python scripts, need to know how to manage a Linux server. This isn't really my wheelhouse, but it may be something that you're interested in. And it's usually a separate role than a software developer. Now, for the rest of this video, when we talk about certain technologies or concepts, I'm going to have the types of developers that it pertains to up in the left-hand corner here. So you'll see something like this with WD for web designer, front-end, back-end, full stack, and DevOps. And this will help you keep track for whatever your goals are. All right, so now we've talked about the different roles, let's talk about some goals and paths that you can take as a web developer. And one thing I want to mention that's really important is that your goals can change over time. So what you choose now doesn't mean you won't change it later. I've been doing this for about 15 years, and I've been a freelancer, a full-time employee, a consultant, an instructor, and I've done side projects. So you most likely won't do the same thing for your entire career. So don't feel like you're stuck with whatever you choose now. So the most common is to learn to code to become a full-time developer for a company. And this is where, you work for a company, you get salary, benefits. Your pay can vary greatly depending on where you live and what company you work for. But it's a very stable job, and you don't have to worry about finding clients or anything like that. You just show up, you do your job. Hopefully you really like coding and you get to, do your passion for work, so it doesn't really feel like work. You get paid quite a bit. There's positions for all types, including the ones that we talked about. Many developers strive to work at like a FANG company, which is, Facebook, Amazon, Apple, Netflix, Google. These are some of the biggest tech companies in the world, and they pay very well. However, there's a lot of companies out there that pay just as well, if not better. So don't feel like you have to work for one of these huge corporations. There's so many companies out there. So freelancing is another option, and this is for developers that are somewhat business savvy. It definitely isn't for everyone. There's a lot of added stress in running your own business, but it can be incredibly rewarding in many ways. You'll probably struggle financially at first, depending on where you're starting out, but if you gain the experience and you put your all into it, you can possibly make much more than you could at a 9-to-5 as a software developer. And freelancing is essentially investing in yourself. And you do need to know quite a bit. You kind of have to be a jack of all trades, master of none, because typically you're starting out solo, so you'll need to do everything from the design to the HTML, CSS, to whatever you're using for a backend, if you do have a backend, or if you're using WordPress. Typically, you're going to go for technologies that allow you to create things fast. And you can also niche down and work with certain industries. So, for instance, you might do medical websites or something like that. There's so many different routes to take within the route of freelancer. So another option you have is to work for a startup, which is a little different than working for a large company. It's pretty risky because most startups do fail. That's just a fact. But if you're one of the first employees, it can be very, very rewarding and you can be very successful and make a ton of money. And then you could also think about starting your own startup later on down the line. I wouldn't say that should be your first goal once you learn how to code. And that kind of leads us to the next one, which is to create a product or a Sass, which is a software as a service. So you could build some kind of app that you could charge monthly for, so you have recurring income. And I would say this is great for a secondary goal. So maybe start off either as a full-time employee or a freelancer and work on a product that you think will be successful in your spare time. And then, if that starts to grow, you could always switch over and do that full time. And then internships, they do offer real world experience. There's paid internships, and even if it's not paid, you do get a lot of experience, and it looks great on your resume for when it is, when it comes time to find a job. And typically, internships that aren't paid, they will lead to a paid position. So it's a great option if, just to get you going in the industry. So these are just some of the things you can do. These are, I would say, the most common, especially the first two, full-time employee, freelancer. There's a lot of things that I would say you can do, but I wouldn't suggest starting out with, like consulting, like teaching, things like that. Again, like I said earlier, you don't have to stick with one thing once you choose that path. All right, so let's get into some of the basic essential tools that you need to start coding. So first, obviously, you need a computer with an operating system. People ask me all the time, what's the best laptop for coding? The truth is you can use just about anything from the last 5 to 10 years for web development. If you were doing something like 3D modeling, then you need a bit more of a powerful computer. But for web development, you don't need much. I'd say just make sure you have at least 8 gigabytes of RAM and an SSD. I think the bigger decision is what operating system you want to use, but even that really just comes down to preference. People ask me what I prefer. I like Mac OS just because things seem to work a bit more smoothly, especially when it comes to things like the terminal. I think that Windows has gotten a lot better though, and I do use Windows, I'd say probably 30% of the time. I just prefer Mac OS for my serious projects. And then obviously you have Linux, which is a great option because you can kind of mimic your production environments, and it's very beneficial to learn Linux server administration if you're going to be doing any kind of DevOps. All right, so again, it just comes down to preference. So a text editor, this is where you'll write your code, and there's a lot of options out there. Personally, I prefer Visual Studio Code. It's free, it's open source, it's very powerful, it's very customizable. I'd say about 80 to 90% of the web developers that I talk to use VS Code. Some other options are Sublime Text, which technically isn't free, but it has a trial that never ends. If you do use it for a long time, I would suggest paying for it. There's Atom, which is free and open source. Vim is also pretty popular. It's a bit more advanced than the others. It has quite a learning curve, but it's very powerful, and the people that use it swear by it. And you don't really have to use your mouse at all, so you can be very, very efficient and fast writing your code. So there's also IDEs, which are integrated development environments. They have a little bit more features than a standard text editor. You don't really need an IDE for most types of web development, but there are some that are geared towards specific languages. For instance, you have PyCharm for Python developers. You have PHP Storm for PHP developers. So that may be something you want to look into, but ultimately, I would definitely recommend VS Code to most people. As far as web browsers go, that's really preference. I'm sure that all of you already have a preference. I like Chrome. There's not really a specific reason. It just does everything I need to. I like the dev tools. I think Chrome and Firefox would be the two most popular. Firefox also has great dev tools, maybe a little better than Chrome. You could even use Microsoft Edge. I came up in the Internet Explorer days, and Microsoft browsers were just horrible. I remember IE6, and it was just a nightmare. But now Edge actually uses Chromium under the hood, so you could just as well use that. Safari, I'm not too crazy about. Brave is really cool for privacy features, Brave and Vivaldi. And then there's a newer browser called Polypane, which is directed toward web development, but it's not free. And personally, I'm not going to pay for a browser. Chrome does everything I need. So it's just preference. And then for terminals, it used to be that front-end developers didn't really need to use a terminal for much, but now with all the framework CLIs and NPM and Git, you do need to know at least the basics. So as far as terminal programs go, I think the default in Mac OS or most Linux distros are great. For Windows used to really suck with terminals with the CMD command prompt. I never really could get into PowerShell. But now the Windows terminal isn't bad. It has SSH. You used to have to use tools like PuTTY. I prefer Git Bash on Windows, which is a third-party bash terminal. But you could also use the Windows subsystem for Linux. It is a bit more advanced, though, so I wouldn't suggest that for beginners. And then for Linux, obviously, you have tons of third-party terminals. You have Terminator, Alacrity. For Mac OS, I'll either use the default or iTerm 2, which just has a little more features, and I think it looks a little better. All right, so now we've come to the first big part of learning to be a web developer, and that is HTML and CSS. So these two technologies are essentially the building blocks of the visual part of the web. HTML is a markup language that's used to structure the content of a web page, and then CSS, Cascading Style Sheets, is the styling language that's used to style the content. So you can think of HTML as the skeleton and CSS as the skin. You can't have one without the other. HTML itself is actually very, very simple. It's just a bunch of tags that you use to structure your content. So as far as what you want to learn about HTML, you want to learn how to create semantic markup. This means using the correct tags for the correct content. You also want to learn about accessibility. This is making sure that your content is accessible to everyone, including people with disabilities. You want to learn all the common tags and attributes, so things like headings, paragraphs, lists. There's a lot of older deprecated tags that you don't even have to bother with. I would say semantic tags, like header and footer are very, very important. So spend some time learning how to structure your pages semantically. And then CSS is a much different, more complex technology. It's a styling language that's used to style the content of a web page. It's very powerful and it's constantly evolving. There's a lot to learn about CSS. You want to learn about all the core properties for things like colors, fonts, the box model, which is how elements are laid out and spaced on the page, and how to use margin, padding, borders. Specificity is important because sometimes you'll have multiple styles that apply to the same element, and you need to know which one will be applied. And the different units of measurements, like pixels, ems, rems, and percentages, you'll want to learn about different types of selectors like classes, IDs. There's also what we call pseudo selectors. You want to learn about the different layout methods like flexbox and grid. These are used to lay out your elements in columns and rows. And then responsive design is really important. All of your projects should look good no matter what device they're being viewed on. There's a few elements to responsive design, but media queries are probably the most important. This is where you can apply different styles based on the size of the screen. So you definitely want to be familiar with responsive design. So next we have CSS Frameworks. Now at this point, these are optional and you could just go right to JavaScript. However, these frameworks can make things much easier when it comes to creating layouts. They're also very popular and a lot of companies use them. And they're pretty easy to learn when comparing it to other technologies like a programming language. So my personal advice would be to spend a week or two learning one of these frameworks. And there's a ton to choose from. However, these are the main four that I would suggest looking at. And to be even more specific, I'd say the first two, but that's just my opinion. So Bootstrap is one of the original CSS frameworks. It's been around since, I believe, 2011. And it's a very widely used technology and has a large community, which is always a plus. It's component-based, which means that there's a lot of pre-built classes that you can use for things like buttons, cards, nav bars, etc. And the upside to this is that you can create UIs and websites really quickly, and you have less classes in your HTML. The downside is that sometimes Bootstrap websites can look pretty similar. Now, it's fair to say that you can really customize Bootstrap and make it look however you want, but you will have to learn Sass, which is a CSS preprocessor, and I'll talk about that in a minute. Bootstrap also has an easy-to-use grid system that a lot of people like. However, I definitely wouldn't suggest using it just for that, because you have CSS Grid or Flexbox, which are built into CSS. So you don't need to use Bootstrap just for the grid. Another plus to Bootstrap is you get a set of JavaScript widgets like modals, carousels, and drop-downs. And this is great for people that don't have a lot of JavaScript experience and still want that functionality. So I'd say Bootstrap is one of the best tools for freelancers because you can create websites and layouts very quickly. Now, Tailwind CSS seems to be the most popular right now as far as, content that you see out there and what people are talking about. You see it everywhere in new projects. A lot of startups are using it. It's a utility-first CSS framework that allows you to build custom designs without pretty much ever leaving your HTML. And being utility-first makes it a bit different than the rest of these, because instead of having a class for, let's say, a button, which would generally have multiple styles, you have a class for each style. So you'll have a class for the background color, for the text color, for the padding. So you almost never have to write any custom CSS because every CSS property has a class. The downside to this is you end up with a ton of classes in your HTML. But the upside is that you can really customize your layout and they don't all look the same, which can be an issue with a lot of these other options. All right, so next we have Balma, which is a newer framework that I really like. It has some good-looking components, and it's really easy to use as far as class names go. It's not as popular as Bootstrap or Tailwind. It's also not as customizable as Tailwind, but it is very fast and lightweight, and I think it looks good. Then you have Materialize, which has been around for a while. It uses Google's Material Design System. And as far as component-based frameworks go, I think Materialize is one of the best looking. Obviously, that's just my opinion. There's a ton of components to choose from, and there's also JavaScript widgets like modals and drop-downs, similar to what you would get with Bootstrap. From what I can tell, its popularity has come down since the release of Tailwind, but it's still a very viable option. And some other frameworks out there are Semantic UI, Foundation, UIKit. I'm not going to go over all of them because they're all pretty similar. Once you learn one, it's pretty easy to pick up another one. So Sass is another option that you may want to learn around this time. It's a CSS preprocessor that adds extra functionality to CSS. So it allows you to write CSS with variables and functions, mix-ins. Native CSS is catching up with Sass features. For instance, we have custom properties in CSS, which are essentially variables. They're not as clean looking as Sass variables, but they basically do the same thing. There's still a lot that Sass can do that CSS can't, though. So you can nest and inherit styles, which is a very helpful feature. I would say learn Sass if you're using a framework like Bootstrap where you need to customize the styles. Also, it can make your CSS very modular, so you can separate it into different files, and then you can import them into one another. And this makes it easier to maintain. You basically create your own CSS framework, and you have a separate file for things like button styles or navbar styles. It's been around for a while. There are other CSS preprocessors like Less and Stylus, but they kind of just faded away. Sass has a really good ecosystem of both command line tools and GUI tools to compile it, because you can't use Sass files directly in the browser, right? You can't just include them like you can CSS. You have to compile it down to regular CSS, and there's different tools that allow you to do that. It's also great for theming, so where you want to have different color options and things like that. It is optional, but again, it's something that's really easy to learn, so why not learn it? You could learn it in a weekend. And I have a crash course that pretty much shows you all the features that you need to know. So next we have a batch of really helpful tools that you'll most likely learn and use early on. So Git is a version control system for saving and versioning your code, as well as collaboration. And I'd say you should learn it no matter what type of developer you are. You don't have to learn it before you start coding, like you don't have to learn it right this second, but it should be on your list as something to learn pretty early on. It's really not difficult to learn the basics. At the very least, just create a GitHub account and learn how to create a repository and push your code to that remote repository. And you can do it through the terminal, through commands, or you can do it directly through your text editor, through the GUI. Markdown is another thing that you should probably learn. It's a markup language that's used to style text, similar to HTML. It's used in a lot of places, such as GitHub. It's used in README files, which you should have for every project that you create. It's used for documentation, and it's very simple to learn. You can literally learn it in a weekend, or even in a day. And the things that you don't know, you can always just go and reference. I forget the exact URL to the Markdown website, but very simple stuff. So next we have editor or IDE extensions. So most text editors such as VS Code, Sublime Text, Atom, they have extensions or plugins that you can install. And Emmet is something that anyone that writes HTML and CSS should be using. It's not even an extension for VS Code, it's built in, but with some text editors you do have to install it. So it gives you really nice shortcuts to create all kinds of HTML tags with classes and IDs and content, CSS styles. It saves a ton of time. It saves you a lot of typing, so definitely something you should learn early on. Live server is another great one that I use all the time. It gives you a local development server that updates as soon as you save your files, so you don't have to go and manually refresh the page. Prettier is something that I use a lot. It's a code formatter that'll help you keep your code clean. You can make it so that it formats your code when you save the file. Another thing that I would highly recommend is to learn the shortcuts of your editor, because it makes you much more efficient and makes you code much faster. All right, so next we have some AI tools that can aid in writing code and problem solving. AI is getting bigger by the day, obviously, almost to the point where it's a little bit scary, but I know a lot of people fear that AI will replace their jobs or replace developers, and I think that may be true to an extent when it comes to basic tasks, but for the most part, I think it's just going to change the way that we write code. It's going to change the landscape and what developer roles entail. My suggestion would be not to worry about it too much and try to utilize the tools that are out there to your advantage to make you a better developer. And the two AI tools that have been pretty much invaluable to me are GitHub Copilot and ChatGPT. So Copilot is an AI pair programmer that helps you write code, and you can install it as an extension to VS Code and many other editors. It's not perfect, but it is pretty amazing, and it helps you be more efficient, saves a lot of time, helps you solve problems. I use it for even things like generating sample data. You can say, give me a JSON file with 20 users with these fields, and it just generates it for you. So really cool stuff. There's others that are similar, like Tab9, Kite. There's a new AI tool that looks really interesting called Cody. I haven't used it yet, but it looks really powerful. And not only can you use it for like auto completion and suggestions, but you also have a chat window where you can interact with it and ask it questions about your project. And not just a single file, the entire project, even if it's, hundreds of files. So really cool. And then ChatGPT is obviously huge right now. It's incredible for learning just about anything. There's a few things that you really have to understand, though, when it comes to using tools like this. The first is that it can be wrong. It can be very wrong, in fact. So you can't just rely on that. I use it kind of as a starting point along with other resources. And the other thing is to make sure that you don't rely on it too much. If you're just using it to generate code and using that code without understanding it, you're not doing yourself any favors. So use it as a learning tool, not as a crutch. And if you find yourself doing that, I'd say don't even use it for now. But if you use it correctly, it can be a great tool. So next we have design tools, and this is another area that you may or may not need to know depending on your goals. And I usually suggest that you learn the basics of design unless you're working strictly back end. As a freelancer, you're going to need to know some of this stuff. I think one thing that a lot of people don't realize is if you plan on freelancing, you have to kind of have an eye for design and be able to create good layouts and good looking websites unless you're outsourcing that work, which you probably can't afford to do when you're starting out. So as far as tools go, Figma is a great tool for designing websites and UIs. That's probably what I would recommend most people. It's free, it's web-based, it's very easy to use. It's not something you need to rush to learn, but it will help you in certain situations. Some others include Sketch, which I believe is still Mac OS only. You also have Adobe products like XD, Photoshop. InVision seems to be really popular for mockups and prototypes. And then you have Canva, Balsamic as well, which are both web-based. Now, while we're on the topic of design, and again, unless you're a backend developer, I usually suggest learning at least the basic principles. And these are some of the ones that I suggest you keep in mind when you're building websites or UIs. So color and contrast is important. Which color palettes look good, the difference in brightness between elements. I see a lot of hero images where I can barely read the text that's against the background image. So you want to make sure that your text is readable. This is one of the biggest and most obvious mistakes that I see. So white space, also important. It's another big mistake I see when people don't have enough space between their elements or they have too much space. Having the right amount of white space can make a huge difference and really improve readability and just the overall experience of the website. Scale is also important. You want to make sure that your elements are sized correctly. You don't want to have a huge button and then a tiny input field, things like that. Everything should be proportionate. And then visual hierarchy, you want to make sure that the most important elements stand out. And you can do this with size, color, contrast. This helps users navigate your website or UI. And it's not only important for how your website looks, but it's also important for how it functions and how successful it is in terms of sales or signups or whatever the goal of the website is. So obviously there's other principles. Typography is another one. You want to make sure that your fonts are readable and consistent, things like that. And I think these are skills that anyone that works in the front end can benefit from. You don't have to be a designer, but you should know the basics. Okay, so everything we've covered so far has to do with creating static websites and layouts and not really any dynamic functionality or interactivity. So that's where JavaScript comes in. JavaScript is the programming language of the browser. Now, how much JavaScript you learn depends on your goals. So if you plan on being a back-end Python developer, then you probably don't need to learn much. But if you want to become a front-end developer, you'll probably end up using a JavaScript framework like React, so you need to learn quite a bit. If you want to be a back-end or full-stack developer and use node.js, then obviously you need to learn quite a bit of JavaScript as well. So this brings me back to why your end goal is so important. Now, people always ask me, how much JavaScript should I learn before moving to a framework like React? And shameless plug here, I do have a course called Modern JavaScript from the Beginning that'll teach you everything that I recommend plus more. It's a 37-hour course. But as far as just, an overview of what I would suggest, I'd say learn the fundamentals first. So variables, functions, conditionals, loops, things like that. Then you want to learn about the document object model, which is how JavaScript interacts with the HTML and CSS. Learn how to select elements and manipulate them. This is what's going to allow you to create things like drop downs and modals and menus, icons you click on and a menu slides out, cool things like that. And then high order array methods are important for working with data. So methods like for each, map, filter. And you should also learn the fetch API so that you can make requests to either a backend or a public API and fetch some data. So you want to learn about HTTP and methods like get, post, put, and delete. And learning about promises and asynchronous code in general is a must with JavaScript. And then learn about JSON, which is a data format that's used to send data back and forth between the client and server. So as a front-end developer, you'll be using the JSON data that's sent from the server. And if you're a back-end developer, you'll be creating or generating that JSON data. So I'd say that that's the minimum that you should learn before moving on to a front-end framework. You can learn more if you want, such as object-oriented programming, classes, prototypes, things like that. But I think that this is a good starting point. All right, so WordPress is a CMS or content management system that's built on the PHP programming language. And I always struggle with where to put WordPress in this guide because technically it is full stack, but you don't need to be a full stack developer to use WordPress or any tool like it for that matter. A very common learning path is to learn HTML and CSS, then a little bit of JavaScript, and then get into WordPress and possibly PHP. That was actually my path back in the late 2000s. So WordPress is especially handy for freelancers. There's a few reasons for that. It allows you to build dynamic websites quickly with little to no coding skills. It's great for clients because they can easily update their own content without you having to create a custom admin area, which can take months to build. There's tons and tons of themes that you can use, as well as plugins to give you certain functionality, both free and paid. I do always recommend that people that want to use WordPress also learn PHP so that they can really customize and create their own themes and plugins. It does make all the difference in the world if your client asks for something specific and you can build it on your own because there's no plugin or theme that does what they want. And believe me, when I started freelancing, I didn't know much PHP and I was using WordPress, and there were a lot of times where I had to tell my client that I couldn't do that, or I'd have to pay someone else to do it. But once I learned PHP, I was able to just go in and customize everything. I should say PHP and JavaScript because there was some front-end stuff. There's also a huge community for support and learning. I think something like 35 to 40% of the web is still run on WordPress, so many like small business websites, things like that. All right, so once you're able to create a basic website or small application, front-end application, you need to know how to actually deploy it to a live server. And this is something that a lot of people don't seem to think about until they're done with a project and they're like, now what? So websites or applications that are just front-end, HTML, CSS, JavaScript can pretty much be hosted anywhere. You don't need to have a server like Apache or Nginx, which we'll talk about later in the backend section. There's literally hundreds of options out there. Some of the most popular services are static hosts like Netlify, Vercel, GitHub Pages. Now, you can use something like Vercel to host like a Next.js website, which is server rendered. In fact, Vercel created Next.js, but they're also great for just plain old HTML and CSS projects. And those three services are extremely easy to use because all you really have to do is push your project to GitHub, which you should already know how to do at this time, and then link your account and choose the repository that you want to deploy. They will give you a URL, they'll assign you a URL, but you're going to want to purchase your own domain for your website, most likely. And there's a lot of services for that. I personally use Namecheap, but there's Google Domains, GoDaddy, there's so many different domain name registrars out there that you can use. And as far as SSL certificates go, a lot of hosting services these days include SSL, so you don't have to really do anything extra. If they don't, and you need to purchase an SSL certificate on your own, you can purchase one from Namecheap. There are different types, or you can get a free one from a service called Let's Encrypt. So that might be something you need to look into. Now, out of the hosting services here, for simple static websites or simple front-end applications or even SSR projects, I prefer Netlify and Vercel. I think they're both very similar. They both offer similar features. You get things like form submissions, serverless functions, logs, and so on. If you're running a business and you need, for instance, business email for your domain name, things like that, then you might want to go with a company like Hostinger or Bluehost. And these companies offer shared hosting, which is very, very cheap, usually under like $10 per month. And these services I'm recommending for mostly front-end projects. When you get into larger full stack or APIs, you're going to need something a little more advanced, something like AWS or DigitalOcean, and I'm going to get into those services a bit later. But I would just suggest taking a look at some of them and seeing what works for you. You know, do your own research on the services. All right, so let's see where we're up to at this point. I'd say if you're familiar with most of what we've talked about, then you're somewhat of a foundational front-end developer or a web designer if you lean more towards design as well. And if you plan on being a back-end developer, a lot of this doesn't really apply to you. However, I usually do suggest learning the basics of HTML, CSS, and JavaScript, even for back-end devs. It just gives you a better understanding of how the front end works and how to work with it. And that's just my personal suggestion, but I know not everybody has enough time to learn everything. So you should have a familiar development environment that you work with, including a text editor or IDE, a set of helpful extensions, some kind of local development server like Live Server, a terminal, although at this point you probably don't need it much, and then you should know the basics of Git and GitHub. So you should know HTML and CSS pretty well, enough to create static websites with responsive layouts, have a good understanding of the box model, knowing some design principles and stuff. That also is very helpful. You should know at least enough JavaScript to create some dynamic elements like modals, drop-downs, tabs, form validation, and just the ability to make pages dynamic and be able to add and remove CSS styles dynamically with JavaScript. And having knowledge about HTTP requests, about the request response cycle, HTTP methods, and using the fetch API, understand asynchronous code and promises. And then you should also be able to deploy a basic website or application to a live server using a service like Netlify or Vercel or whatever it is that you choose. Now, CSS frameworks, like I said, are optional, but in my opinion, are recommended. I would suggest either Bootstrap or Tailwind. They're easy enough to learn, and they do help you, style your websites much faster. Sass is also optional, but recommended as well because you can learn it really fast. And I think I mentioned this, but I might not have, but it's really important to learn CSS before you jump into any kind of CSS framework. Just like with JavaScript, you need to know fundamentals before you move to a JavaScript framework. Some of you may choose to go the WordPress route, especially if you're going to be freelancing. If so, you should know how to install and set up plugins, themes, widgets. Also, work on learning how to create your own themes and plugins once you're ready to start learning PHP. As far as jobs go, you could start applying with this knowledge, but typically front-end positions are going to want you to know a framework like React or Vue, so you might want to learn one of those first. In my experience, there are a lot of jobs that are willing to train you if you do know, if you're familiar with JavaScript, but you just really haven't gotten deep into a framework yet. Some companies are willing to train you on that. You could also start freelancing at this point. You could create websites for small businesses and individuals, so it's really up to you on where you want to go next. Now, from here, it really depends on what you want to do, and I think there's a few different paths you can take from this point. So let's say that you want to be more of a web designer or work for a small agency or freelance. You might choose to learn more about design, get better at CSS, maybe get more into WordPress or even some no-code tools like Webflow. You probably want to learn some SEO practices as well because that's something that a lot of clients will need. This route usually is a mix of coding and business, and you work really close with clients and other businesses. You may even get into some marketing. I did this for quite a few years myself. You could also go the full-blown UI UX designer route, which is kind of out of the scope of this guide. But maybe you find that you're better at design than coding. I've seen a lot of people do that. They start off wanting to be a web developer, but they end up getting more into Figma or Adobe XD, and they get more into the design side of things. So that could be an option as well. And then the next option is to proceed with the front end, and this is probably the most common among my audience, at least. If you're more into the coding aspect and you want to work for a company as a front end or even full stack developer, you can continue to learn more about JavaScript and learn a framework like React, Vue, or Angular. All right, you can learn about UI components and state, front-end workflows and build tools like Webpack and Vite, static site generators like Gatsby, and SSR frameworks like Next.js. You'll also learn about testing and performance. This route is much more focused on coding and less on design. And again, this could be for you whether you plan on being a front-end or a full-stack developer. And I want to stress that if you do plan on freelancing, you can still proceed with this particular path it can be really beneficial to learn something like React and maybe a static site generator like Gatsby and use that along with a headless CMS. That's a good stack for a freelancer because you can create things that are very dynamic and you can create them really quickly. And I'll talk more about that stuff soon. Next, if you want to be a backend developer or a full stack developer and just start with the backend next, you can take this approach. So you can move to a server-side programming language like Python, C#, PHP, or stick with JavaScript and learn a runtime like node.js, or even a newer runtime like Bun.js or Dino. So you'll also need to learn a backend framework like Express if you're using Node, Django for Python, Laravel for PHP, maybe ASP.NET if you're getting into C#. So lots and lots of choices, and we'll get into all of that. And then you're also going to need to know about databases, so either relational or NoSQL databases. With this option, you'll be creating APIs for front-end developers to work with. If you're going full stack, then you'll be creating and consuming APIs. You may also want to learn a little bit about DevOps and how to deploy server-side applications and APIs to production. So I'm going to continue with what I see most people do and move further down the front-end developer path. So we're going to take the middle option here. Now, before we look at front-end frameworks and ecosystems, I want to address a change that's happening where the front end is evolving quite a bit. And this may seem complicated and overwhelming at first, but I think we're headed in the right direction. So websites started off with a traditional multi-page server-rendered approach. So think of like a PHP website. Each distinct piece of content is presented on separate HTML pages, whether it's static, whether you create those HTML pages, or they're generated by some kind of server-side language like PHP. And this is still a common approach. It's great for SEO, but the UI isn't as fast and dynamic as if you were to use a front-end framework like React, which for many projects is absolutely fine. Then these front-end frameworks come along and changed it up where we're building single-page applications or SPAs, and this is where the entire UI, the entire application or front end is bundled into a JavaScript or multiple JavaScript files, and the browser loads a single HTML page. So when you click on a link, it doesn't actually go to a new page like it would for a traditional HTML or PHP site. It just changes the URL, and then JavaScript handles the rest. And this makes the site very dynamic. It gives you a very fast and interactive user interface on the client side, but it's not great for SEO and it can lack performance in some areas. So now we have what are called SSR or server-side rendered websites. This is where the page is initially rendered on the server by default and then sent to the browser, similar to traditional websites. However, we can still have that interactive, fast user interface by using client-side components in frameworks like React and Vue. So you really get the best of both worlds. And we do this through what are called meta frameworks or SSR frameworks. There's different names for them, but some examples are Next.js, which you can use React and you can have your pages server-side rendered. Nuxt.js for Vue, you have SvelteKit for Svelte. So I'll talk about those technologies in a bit, but that's kind of the approach that we're starting to see more of now. Now, in addition to that, you have static site generators like Gatsby, Gridsome, Astro. Next.js is also a static site generator. And these are frameworks that allow you to build static websites with React, Vue, Svelte. So you can have a static website with a dynamic UI. And I know that sounds a bit confusing, but I think it's a good thing because it gives us more options and allows us to build better websites or more interactive websites and applications. So instead of talking about front-end frameworks and then talking about SSR and static site generators, I'm going to talk about them all together as an ecosystem. I think that makes more sense. So if you're a React developer and you want to learn SSR, then you're probably going to use something like Next.js or Remix because you already know React. You just need to learn the Next.js way of doing things. Now, since this can be confusing, especially for beginners, I always say start with a single page application. If you're learning React, just start with SPAs using Create React App. I'll talk about that in a minute. and basically go with whatever's in the framework's documentation. Then once you're comfortable with that, you can move to a meta framework like Next.js. So think of it as you're not just learning or getting into React or Vue, but you're getting into that entire ecosystem. And that can include SSR, SSG, state management, mobile frameworks, UI component libraries, and more. So you don't have to learn all these things, but the more you learn, the more types of projects you can build. Now, there's a crap ton of frameworks out there, but these are the big four. You have React, Vue, Svelte, and Angular. And I would suggest learning one of these because if you choose some obscure framework, it could go away at any point, and no longer be supported. And there's probably not much of a community. You may have a hard time finding a job, so I would stick to one of these. And I'm going to go over each one, and then after that, we'll go over the ecosystems of each one. So we'll start off with React, which is a front-end framework that was created in 2013 by Facebook. And I would say it's the most popular front-end framework. It's been around for quite a few years now. There's quite a few React jobs out there in many areas. So if you're looking to work as a full-time developer, then React is a good choice. It's a component-based framework, as are all of these, and it uses JSX, which is a syntax extension to JavaScript. So it basically allows you to write HTML within your JavaScript and within your components. It's not required with React, but it's the most common way to use it and the most common way to write components. Now, and when I say components, I'm talking about pieces of the user interface. So a search input, a nav menu, an article, whatever. You start to think of your website in terms of UI components. Now, technically, React is a UI library and not a framework. However, it's so popular and has such a huge ecosystem that I think it's fair to call it a framework. And it's a direct competitor to frameworks like Angular. And just know that React is a library, so you'll most likely be installing a lot of other packages. React does have one of or I'd say the biggest ecosystem, and that's not necessarily a good thing because it means that the framework itself is pretty bare bones and you'll need to install other packages to do things like routing, etc. I'd say it's pretty middle of the road when it comes to the learning curve. There are some things that might make you scratch your head and things that are a bit easier to do in other frameworks, especially when it comes to state. However, it's much easier than something like Angular, at least in my opinion. It's also pretty quick to get something up and running with. Now, when it comes to performance, all the frameworks are pretty impressive. It's hard to really gauge this because it depends on the project and how you write your code. React is generally more performant than Angular. It's also much lighter, but it's not as performant as something like Svelte. But again, it depends on the project and how you write your code. You can use things like memoization and lazy loading, things like that to improve performance. Now, there's also a lot of jobs in React in most areas, of it, at least in the US. I'm not really familiar with other countries. And this is definitely a good reason to get into React, but it shouldn't be the only reason. If you hate writing React, you may be better off using something that you like, even if there's less jobs. And remember, if there's less jobs, there's probably less competition as well. Also remember, when there's a lot of jobs with a certain technology that's really popular, a lot of people know that technology. So you have to weigh the pros and cons. Next, we have Vue.js, which is a framework that was created by Evan You in 2014. And it gains more popularity every year. Just the fact that it wasn't created by a tech giant like Facebook or Google and is still one of the most used frameworks is pretty impressive, and it shows that it's a great framework. One of, if not the main focus of Vue.js, or main focuses, is simplicity and performance. And it is component-based, of course, just like the rest of these, and it uses a template syntax that's very similar to HTML. And Vue components are very simple. There's an area of the template for the output, or the HTML, the logic, or the JavaScript, and the styles. And there's two different ways to write your JavaScript in Vue components, now, at least with since version 3. There's the options API, where your component is an object with properties and methods, and then the Vue version 3 introduced the composition API, where it's you have a setup function and you return the data and methods from that function. I'd say the options API is a bit easier to learn, but the composition API is more powerful. That's just my opinion, though. So like React, Vue is also very lightweight, and on its own, it has a pretty similar ecosystem to React when it comes to, SSR and SSG frameworks and so on, and we'll take a look at those soon. I would say that Vue is one of, if not the easiest frameworks to learn. Of course, I'm saying that relative to the others. It's also very powerful, and it has a lot of the same features as React. So as I said, Vue has a focus on performance, and it's very fast, has a very small bundle size. So next we have Angular, which was created by Google, and there was a version back in the day called AngularJS, I believe around 2010, and the entire framework was revamped for version 2, which is just Angular. So if you hear AngularJS and Angular, they're usually two different frameworks. So if you just go by the content and things like YouTube and Twitter and things you read online, you might think that Angular is kind of dead. However, it's still very much alive and used by a lot of really large companies and enterprise level projects. So I don't think it's going anywhere anytime soon. The others are more popular with startups, smaller companies, individuals, and of course they're also used by really large companies. But you see mostly React and Vue if you're looking at YouTube tutorials and videos and stuff like that. But yeah, Angular is a true full-featured and opinionated framework, meaning that there's certain ways to do things. Where with something like React, you have much more freedom and there's a million ways to do the same thing. Now, Angular includes a router, it has its own HTTP client, it has its own services, animations, and much more. It also uses TypeScript by default, which is a superset of JavaScript that lets you use types. And you can use TypeScript with any framework. However, it's the norm, it's the default for Angular applications. And it also ships with the Angular CLI, which is a command line interface that allows you to create an Angular application with virtually no configuration. And it's used to build and deploy your app. Not only that, but you can set your project up to be a SPA, so a single page application, or an SSR, or a pre-rendered static site. So the ecosystem as far as third-party tools is much smaller than React or Vue because, again, so much is included in the framework itself. I think Angular has a pretty steep learning curve, and I don't usually recommend it for beginners unless they're going to be working for a company that uses it. But that's just kind of my opinion, and it seems to be the opinion of a lot of people. The bundle size is larger than others, which is expected because it's so full-featured. However, it's still pretty fast for what it is. For most projects, the bundle size isn't going to be an issue anyway. So the last one we have is Svelte, which is a modern JavaScript framework for building web applications that takes a kind of a different approach. In fact, technically, Svelte is a compiler, and it focuses on shifting a lot of the work that's traditionally done at runtime to compile time. So other frameworks, like the ones we just talked about, use what it's called a virtual DOM, while Svelte compiles your components into highly optimized vanilla JavaScript code during the build process. So this results in faster and more efficient applications, and it's also the most lightweight of the four. As far as writing code, Svelte offers a simple and intuitive component-based approach where components are written using a clean HTML-like syntax with JavaScript logic embedded directly within them. So when you write Svelte code, it feels a lot like vanilla JavaScript I'd say out of all the frameworks. It's almost like what you wish JavaScript would be on its own in terms of how you create events and dynamic interaction with HTML. Svelte has a pretty easy learning curve. I'd say Svelte and Vue are definitely the easiest to learn. It has a very straightforward development experience, which makes it an attractive choice for building modern web applications. The downside to Svelte is that it's fairly new, so when it comes to finding jobs, I just don't see a lot of them. And I'm not saying that you can't find a job as a Svelte developer, but there's a lot more React, Vue, and Angular jobs out there. And it's a great framework on its own, though, and I would suggest checking it out. Now, the ecosystem for Svelte is really small because there's an official meta framework called SvelteKit that pretty much includes everything you need to build a full stack application. You can build spas, SSR, static websites. It handles all the routing, the building, the dev server, and much more. All right, so now I want to talk about the ecosystems for each of the 4 frameworks. And instead of showing you a page with all the SSR frameworks, all the static site generators, I'm keeping it within that particular framework's ecosystem. And some of this stuff are tools that are built into the framework, but most of it is third-party tools to add functionality. And I'm going to start with React because it has the biggest ecosystem, and then I'll talk about the others. And you're going to see that most of what is available for React is also available for the others, whether through native features or through third-party packages. So we'll start with Create React App. That's probably what you're going to start with if you're just starting to learn React. And this is more of a traditional way to use React. It's a CLI, a command line interface, that allows you to spin up a project with no configuration. It's great for beginners, and it's what you would use to create a SPA or single page application. So you could install React manually if you wanted to, but I wouldn't suggest it because Create React App gives you additional features like hot reloading, gives you a dev server, service worker, and more. And it's built on top of the Webpack build tool. And you can eject from Create React App if you want to customize the configuration and really dig into Webpack, but I wouldn't suggest that unless you really know what you're doing. Now, as I said, React is referred to as a framework, but it's technically a UI library, and it doesn't have some of the essential things that you would find in a framework, and a router is one of those things. So with a single-page application, you need to manually define your routes. It's not like an SSR framework where you just put a file into a certain folder and then it's accessible. You need to install the router and you need to create your routes. And the most popular way to do this is with React Router, which is the official router that you would use. And you'll typically learn about this along with React. It's very easy to use, it has a lot of features, and it's very well documented. Now, when it comes to managing state or data in your application, you have component level state, which just pertains to that component, which is pretty easy to handle. But then you have app level or global state, where you need to share that data between multiple components. Now, in my opinion, React isn't the best with state management out of the box. There is a built-in context API that you can use along with some hooks, but it's fairly difficult for beginners to grasp. Also, if you're building something with a lot of state, you might have to reach for a third-party solution. So Redux has always been pretty popular. Redux also isn't the easiest thing to deal with. I think Redux Toolkit makes it a bit easier. That's a library you can use on top of Redux. You also have MobX, which is a popular state management tool. There's some others like Zustand, I'm not sure how to pronounce it, but that's gaining some traction. Recoil, Xstate. There's a lot of different ways you can manage state within React, but I would say learn the native features first. Learn the context API, learn the use state hook, use reducer hook, and so on. Now, when we get into the server-side rendered frameworks, I think that this is where React's ecosystem really shines. Next.js is a great framework and just great platform to build React projects with. It uses React server components, so all of your components are actually rendered on the server by default. And you can fetch and load data very easily from the server. You can also make them client-side components and make them dynamic just by adding a single line at the top saying use client. Next.js also is a static site generator, so you can create static websites. Then you have Remix, which is another SSR framework that's built on top of, it's actually built on top of React Router. And it's very similar to Next.js. It's a bit more difficult to learn in my opinion, but it does have some features that Next doesn't. And I do have a crash course on both if you want to check them out. SSR websites are great for SEO and performance. You really get the best of both worlds, like I said earlier. And you can also use something called a headless content management system like Contentful or Sanity, and I'll talk more about those later. But those pair really well with SSR frameworks. Now, Gatsby takes a different approach compared to traditional single-page applications or SSRs. It's a static site generator. So instead of rendering content on the client via JavaScript, Gatsby generates static HTML files at build time. So this approach results in really fast load times and improved SEO. So it's built on top of React. So if you already know React, you can easily jump into Gatsby. It has a data layer that uses GraphQL, which is a query language for APIs, and I'll get a little bit more into that later. But yeah, Gatsby and Next.js are both used to create really fast static websites. And again, you could use something like a Headless CMS for your data and use the static website as your front end. So, of course, you can write your own CSS and styles, but you might want to use a UI component library or UI kit. These are pre-built components that you can use in your application, and they're great for beginners because you don't have to worry about styling. You can just import the component and you can use it. So there's a bunch of these. Material UI is a really popular one. It uses Google's material design pattern, and it's very customizable, has a ton of components to choose from. Some other popular ones are React Bootstrap, which has pre-built Bootstrap components. Chakra UI, which I really like, I think has some really good-looking components. And then you also have a library called Styled Components, which is a CSS in JS library that allows you to write CSS in your JavaScript. So this is it doesn't come with pre-built components like the other ones do, but it allows you to essentially create your own pre-built components. So another part of the ecosystem is React Native, which allows you to build native mobile applications using the React framework. And what's great about React Native is that you can use the same code base for both iOS and Android. Usually when you build native mobile apps, you have a separate Swift code base for iOS, either Swift or Objective-C, and then you'll have a separate Kotlin or Java code base for Android apps, where with React Native, you have just one app for both. And it's also great for web developers because you can essentially use your JavaScript skills to build mobile applications. So those are the main parts of the ecosystem, but there's plenty of other smaller things you might find yourself using, such as React Query, which is a library for fetching, caching, and synchronizing data. You have libraries to work with forms like Formic and React Hook Form, React Testing Library, and many other libraries to test your React applications. There's libraries for animation. There's even frameworks and libraries for using React to build VR, so virtual reality and augmented reality environments. You certainly don't need to learn all of this, but if you learn React, you can get into all this stuff pretty easily. So the Vue.js ecosystem almost seems to mirror React's. It has a lot of the same features and tools. So Create Vue is similar to Create React App, but just for Vue.js. It's a CLI and scaffolding tool to create a single-page application. And it's built on top of a build tool called Vite. So Vite is a newer build tool that's much faster than Webpack. We used to use something called the Vue CLI, which is still around, but I don't think it's supported anymore. I would just suggest using Create Vue if you're building a spa with Vue.js. And then Vue Router is the official router for Vue.js. It's very similar to React Router. It allows you to create routes for your application. It's very easy to use, very well documented. Now, state management with the native Vue.js is pretty easy compared to React, just by the way components are structured. But there are tools if you need more advanced state management. So Vuex used to be the official state management tool for Vue, but now it's called Pinia, which works in a very, very similar way to Vuex. And it allows you to share your state across components and pages, and it works, of course, with Vue version 2 and version 3. You also have other options like XState, Harlem, and there's a lot of other third-party tools you can look into if needed. And then Nux.js is very similar to Next.js. It's a server-side rendered framework or meta framework for Vue.js. It's great for SEO and performance. It's also a static site generator. So it includes most of the features that Next.js does as far as file-based routing, server components, data fetching utilities. It uses the Nitro server engine. If you're a Vue developer and you want to get into SSR, you're probably going to be learning Nux.js. And then Gridsome is a popular static site generator built on top of Vue, and it's very comparable to Gatsby. And it's ideal for building fast and efficient static websites, blogs, documentation sites. It's also it also uses a GraphQL data layer, just like Gatsby. So you can kind of see the pattern here. Everything that React has, Vue basically has in its own right. And then as far as UI libraries go, Vuetify is probably the most popular. It's similar to Material UI for React. It's based off of Google's Material design pattern, very customizable, tons of components, probably what I would recommend, but there's others as well. If you want to use Bootstrap components, you have Bootstrap Vue. I believe there's also one called VueStrap. You have Quasar, Buffy, which uses the Balma framework, so tons of UI kits available. And then as far as mobile development, there's not really something that's directly comparable to React Native. You do have NativeScript or NativeScript Vue, but NativeScript you can use any framework with. You could even use React with it. And it has access to native APIs. So you can essentially create a native mobile app with Vue and have a single code base for both iOS and Android. And then some other things you might run into are Vue Query or TanStack, which is basically the React query for Vue. It's a way to fetch and cache data. You have Vue testing utilities. You have native animations that you can use that's built into the framework. And then for virtual reality, you have Vue VR. So just some things that I figured I'd throw in that you might find in the ecosystem. Now, for Angular, the ecosystem isn't as big, or I should say a lot of the stuff is built into Angular itself because it's a much more full-featured framework. So you're not reaching for as many third-party solutions. So the Angular CLI is the official command line tool for Angular. It allows you to create, build, test, and deploy Angular applications. And it's similar to Create React App and Create Vue. It's built on top of Webpack, and it's pretty easy to use, also very well documented. You can enable SSR with Angular CLI, which is pretty cool. It was initially called Angular Universal, the SSR framework, but that repo has been merged with the CLI. There's also options to pre-render your app, which is similar to static site generation. Now, the Angular router is the official router for Angular, and it's very similar to React Router and Vue Router, except it's built in. You don't have to install it separately. And it includes things like route guards. It even has some animation options. So very cool. Now, as far as state goes, one thing I really like about Angular is the concept of services. This gives you an easy way to manage your state because you can inject a service into your components and you can share data from that service across your entire application. Okay, you also have NGRX, which is the official state management tool for Angular. It's similar to Redux. It's actually built on top of something called RxJS, which is a library for reactive programming using observables. So dealing with asynchronous code, similar to promises. And it's a bit more complex than other state management tools, but also very powerful. And it's great for larger, complex applications. And again, for SSR and static sites, you can just use the CLI. So there is no Next.js or Nuxt.js for Angular. It's all included and bundled in the CLI. For UI kits, Angular Material is pretty popular. You also have NG Bootstrap, PrimeMG, Clarity, and a bunch of others as well. With that, you just kind of have to go through and see which ones you like, what components you like the look of, and so on, if you even want to use a UI kit. And then for mobile apps, you can use NativeScript just as well as you can use it with any framework. You can also use Ionic for hybrid apps, which I'll talk about later. And then as far as other tools you might find yourself using, obviously TypeScript, because that's the default with Angular. Some other packages I've used are Angular Fire to work with Firebase, which we'll also talk about later. Formly for forms, and Angular Testing Library for testing. And testing is built in with the CLI as well. So Svelte is newer than the other frameworks. It doesn't have as big of an ecosystem because it has an official meta framework called SvelteKit, which is awesome. I really like the way that Svelte does things. It's a full stack framework that allows you to build single page apps, server-side rendered apps, and static websites. So it's basically an all-in-one tool, and it's great for SEO, it's great for performance. It's similar to Next.js and Nuxt.js with some elements of Gatsby and Gridsome. So you can basically build whatever you want with Svelte. And it's built on top of the Vite build tool. Sapper was the original meta framework for Svelte, but it's no longer supported. So SvelteKit is basically the new version of Sapper. And state management is really well integrated. You don't really need to reach for a third-party solution because SvelteKit has a context API and built-in readable and writable stores that you can use to share data between components. Of course, if you want, you can use a third-party state manager, but I think for most types of applications, the built-in functionality is really all you need. And there's also a bunch of UI kits like Svelte Strap, which is a port of Bootstrap for Svelte. There's Carbon Components, which is a port of IBM's Carbon Design System, as well as Flowbyte and some others. So the way that Svelte does it, I think, is the way to do it. Just have everything bundled in a single official meta framework. Now, you can see that a lot of these framework ecosystems basically all copy each other. They all have the same features and tools, so it really comes down to which one you like best. You can pretty much build the same stuff with any of them. Some might be a little more performant than others, but they're all pretty fast. So those are the big front-end frameworks and ecosystems, and I know that it's a lot of information, but I think it's important to know what's out there. And what I suggest is just trying each one out and seeing what kind of vibes with you. A lot of people on the internet like to say this one's great and this one sucks. Don't ever let that be the deciding factor. Try them out for yourself and see what you like. I think they're all great and they all have their pros and cons. All right, so let's talk a little bit more about TypeScript. I mentioned it a couple times, but didn't really talk about what it really is. It's available for front end and back end if you're using something like node.js. And TypeScript is a superset of JavaScript, meaning that it is essentially JavaScript. It is the JavaScript language, but with some added features. So anything you can do in JavaScript, you can do in TypeScript, but then in addition, you have features such as static typing. That's kind of the main addition to it, is that JavaScript by default is a dynamically typed language, which means that you don't specify the types of your variables or function return values. You don't say this variable is a string or this one's a number, but TypeScript allows you to do that. And you might say, well, why the hell would I want to do that? Why would I want to write more code when I don't have to? And it's kind of hard to explain until you use it and really see the benefits. It's not for everyone, but I think it's worth learning. I think that having types does require more code, but it also makes your code more robust and less prone to errors. It also makes your code more descriptive and readable, and if you use something like VS Code, it will give you more IntelliSense and show you, what properties and methods are available for or what you're missing. So there are a lot of reasons to use TypeScript. All right, so headless content management systems are becoming more and more popular, and they allow you to create content in a user interface similar to what you would do in a WordPress admin area, and then they generate an API from your content, and you can use that API in whatever front end you'd like. And these can also be useful for freelancers because clients can log in, they can update their content easily. And of course, you could create your own custom admin area for them, but that takes way more time and money. And these are really popular with static site generators like Gatsby, as well as SSR frameworks like Next.js or Nuxt.js. So let's just take a look at a few of the popular ones. There's tons of these out there. So Sanity or Sanity.io is a headless CMS that can be used by projects of all sizes. Companies like Nike and Figma use Sanity. There's a free option for personal projects, but you can also pay for plans for teams for really large projects. So it can be good for really complex applications or something like a personal blog. Contentful is another popular headless CMS that has a ton of features. It's used by companies like Spotify and Urban Outfitters. It's also free for personal projects, and you can pay for plans for teams. And there's also extensive integrations available. So Strapi is a free and open source headless CMS that's built on top of Node.js, and it uses a MongoDB database. And it's great for small to medium-sized projects. It's also very customizable. I like Strapi because it's open source and you host and manage, or you can host and manage everything yourself. The interface is pretty easy to use as well. It can generate a REST API or a GraphQL API from your content. I do have a crash course on Strapi if you're interested. I also have a crash course on the next one, which is Prismic, and this is another headless CMS that uses a structured content model based on slices, and it allows content creators to build dynamic page layouts with reusable components. And this is good for allowing non-technical users or your clients to create versatile content. And then HighGraph is a new product that looks pretty cool. It's not something I've used. It's a headless CMS with e-commerce capabilities. So you can build an entire shopping platform API, and it integrates seamlessly with payment gateways. It also uses GraphQL. Again, I'll talk about GraphQL in a little bit. Now, if you haven't used WordPress in a while, you may not know that in addition to the traditional WordPress CMS, it also has headless capabilities, and you can generate a REST API from your WordPress content. And it's easy to get up and running. It gives you the powerful WordPress admin interface without being bound to the front end, without being bound to WordPress themes. So you can use anything you want, React, Vue, Svelte, whatever. So this can be really good for freelancers as well. Now, like I said, there's a ton of these, and I would just suggest taking a look at a few of them and seeing if you like it, see how the API can be generated and how you can integrate it into whatever it is you use in your front end. Now, there are some other newer, smaller frameworks and other tools that I want to mention. I'm not going to go into detail about them, but I'll give you a brief overview. If you're just starting out and learning one of the big frameworks, you don't need to worry about these just yet, but if you're a more experienced developer, you may want to check them out. So Solid is a declarative JavaScript library for creating user interfaces, and it's built on top of JSX, which is the syntax extension to JavaScript, very similar to React. In fact, the framework overall is very similar to React. And Solid.js's reactive rendering is one of its standout features. It uses fine-grained reactivity to update only the parts of the DOM that actually change, resulting in high performance and minimal re-rendering. So it's fairly easy to learn. I still need to create a crash course on it. It's not as popular as the other frameworks, but it's also much newer and it's growing in popularity. So I won't be surprised if we see a lot more of Solid.js. Alpine.js is a minimal framework for composing JavaScript behavior in your mockup, so in your HTML, and it's quite different than the other ones we've talked about. In fact, I wouldn't even put it in the same category. It's more of a utility library. It's very small, and it's great for adding some dynamic elements to your website without having to learn a full framework. And you also don't have to write any JavaScript. It almost makes HTML function as if it were a programming language. So you can have conditionals and loops and stuff like that within your HTML just by using special tags. So if you have a basic website and you just want to add like a drop down or a modal, you can do that easily with Alpine.js, and there's no need to learn a full framework. It also pairs well with Laravel templates, or you can use it with Django and frameworks like that. And then HTMX is another really cool technology. It's a JavaScript library that allows you to create dynamic front ends, again, without writing any JavaScript code. And it does this by allowing you to use special attributes in your HTML to make HTTP requests and then update the DOM. So it's actually similar to Alpine, but it's more focused on making HTTP requests. And it's great for adding some dynamic elements to your website and making requests to an API or a backend without having to learn a full framework. And I think Alpine and HTMX are great technologies that work much differently than traditional frameworks. So I would definitely suggest checking them out. Now, Astro is one of my favorite new frameworks. It's actually a static site generator as well as an SSR framework, and you can also create API endpoints with it. I just did a quick start course that's available on YouTube and on my website. What's really cool about Astro is that it builds zero JavaScript by default. It actually renders the HTML pages on the server and uses an architecture called islands. Also, you can use Astro components, which are very simple and straightforward, or you can use React components, Vue, Svelte. So it's sort of like a Next.js, but it's not bound to React or any other framework. It's also built on top of Vite, which again is a very fast build tool, so definitely worth a look. Stencil or Stencil.js is something that I haven't used yet, but it's a tool chain for building reusable, scalable component libraries. It was built by the Ionic team, and it's a compiler that generates web components. So you can create your own components, and you can basically use them in any framework you want or in just vanilla JavaScript. So JSDoc is something that has been around for a while. I actually did a crash course on it years ago that I forgot about, but I'm seeing a lot of it lately where people are using it in place of TypeScript. And it's actually an API documentation generator for JavaScript, but it can be used to add types to your JavaScript code. It's not as robust as TypeScript, but it's a lot easier to get into. And I'd suggest looking into it and seeing if it's something that you might benefit from. All right, so in addition to tools, languages, and frameworks, you also have a lot of web APIs available in the browser that you should be familiar with. And I'm not going to go over all of them, but I'll list some of the common ones here. Many of these are easy enough to learn. I just suggest spending a little bit of time on them. So the Canvas API provides a means for drawing graphics via JavaScript and the HTML canvas element. Among other things, it can be used for animation, game graphics, data visualization, photo manipulation, real-time video processing, and much more. So Canvas API, probably something you want to check out. And then the geolocation API allows users to provide their location to a web application if they so desire. For privacy reasons, the user is asked for permission before they accept to show their location. But this can be very useful for things like maps, weather apps. You can custom tailor the experience based on the user's location, things like that. The Web Storage API provides mechanisms for the browser to store key value pairs in a much more intuitive fashion than using cookies. It also allows you to store more data than cookies, and you can store data locally or session-based. So this is also called local storage and session storage. Now, the Web Workers API makes it possible to run a script operation in the background thread separate from the main execution thread of a web application. So this allows for long-running scripts that are not interrupted by scripts that respond to clicks or other user interactions, and allows long tasks to be executed without yielding to keep the page responsive. The WebSockets API makes it possible to open a two-way interactive communication session between the user's browser and a server. And with this API, you can send messages to a server and receive event-driven responses without having to poll the server for a reply. So this is great for chat applications and other real-time applications. Then you have the web and video APIs. Obviously, these allow you to create and manipulate audio and video content. You can create audio and video players, record audio and video, and even create audio visualizations. So some others you might want to look into are WebRTC for real-time communication and video streaming, the Bluetooth API, the Web Search API, things like that. They're all fairly easy to get into once you learn the basics of JavaScript, so I'd suggest learning about them and maybe building a small project with some of them. All right, now testing is something that you may or may not get into. Testing ensures the reliability, functionality, and security of your applications. And I would suggest looking at your project load to see if testing would be beneficial. I'm actually creating a video now that goes into all of that, so it should be released by the time you watch this. Now, if you're freelancing and you're using something like WordPress or building static websites, you won't need to worry about testing. But if you're building larger, more complex applications, it can be beneficial. Or if you're working for a company that requires you to write tests, then obviously you need to learn it. But I think it's a good idea to at least see how testing works, check out some of the libraries and some of the different types of testing. As far as the different types, there's a lot of them, but I'd say the most common are these three. You have unit testing. This is where it pertains to individual units of code. This is probably the most common type in web development. Then integration testing is the process of seeing how different elements of your application work together. And then you also have end-to-end testing, which is the process of testing your entire application from start to finish. And every programming language has testing tools. I'm not going to go over all those, but just some of the popular ones. Since we're talking about JavaScript, Jest is very popular. It was built by Facebook, and it's pretty easy to use. It includes built-in assertion libraries, mocking capabilities, powerful features like snapshot testing. Mocha is another highly flexible testing framework for JavaScript. If you're looking to run end-to-end tests, Cypress is a good option. It's JavaScript-based testing that allows you to write tests that run in the browser. And then Enzyme is a JavaScript testing utility for React. You also have React testing library. There's just so many of these, and I can't go over all of them for every language, but definitely something you want to look into if you're looking to build really complex applications. All right, so if you've learned most of what we've talked about, then I'd say you're a pretty advanced front-end developer. So if you're fluent with a front-end framework, whether it's React, Vue, Svelte, Angular, as well as their ecosystems, so have some front-end tooling skills, so you should know how to use NPM to install packages, CLI tools, module bundlers like Vite and Webpack, and then server-side rendering. That's definitely something that a couple years ago I would say is optional, but now I think that it's something that you need to get into. So if you're becoming a React developer, then you should be learning about Next.js or Remix, SvelteKit, Angular SSR, Nuxt.js, whatever it is. Server-side rendering, I think, is the future for a big part of web development. And then static site generators, also very useful if you want to build really fast, performant websites. Headless CMSs are obviously optional, but they're really helpful. Again, especially if you're freelancing and you want a way for your client to be able to update their own content, but use whatever you want on the front end. So really cool stuff. And then some additional tools such as TypeScript, Alpine, HTMX, some of the newer technologies you might want to just mess with and get into. Web APIs, I would say you should understand a lot of the common APIs that are available, like Canvas, the speech API, geolocation, things like that. So now that we've gone over the front end, let's talk about the back end. And if you want to be a full stack developer or a back end developer that creates APIs, microservices, you need to learn a server-side language or server-side technology. And this is where you start to get a lot of options. Really, you can use any language that you want that has HTTP capabilities, but I'm going to go over some of the most popular choices, and I'll give you some stats at the end of this section as well. So the first option I have is JavaScript, right? JavaScript was initially created for the browser, but now we have these runtimes that allow us to use JavaScript as a server-side language, a very fast server-side language. Node.js being the most common, and definitely what I would suggest if you're just getting started. There are some newer interesting options to play with if you already know Node.js. Dino is a newer runtime that's built by the same person that created Node. It's very similar to Node, but it has some interesting features like built-in TypeScript support, built-in package manager. Bun.js is even newer and more interesting, and I'm actually going to have a slide dedicated to that towards the end. But Node.js is very popular for building APIs, microservices, as well as full-stack applications. It's non-blocking and event-driven, which makes it highly efficient for handling concurrent connections and I/O-intensive tasks. What it's not good for is CPU-intensive tasks. So if you're building something that requires a lot of processing power, you may want to look into something else. But Node.js is great for just about everything that has to do with web development. So anything where we're just doing CRUD operations, create, read, update, and delete, working with databases, etc. It's built on the V8 JavaScript engine, which is the same JavaScript engine that powers Google Chrome, and it's also pretty easy to get started with. Now, you'll need to learn about NPM, which is the Node Package Manager, and you can use it to install all types of packages and libraries. If you're familiar with a front-end framework, then you already know how to use NPM because it's used on the front end as well. You'll need to know about the Node.js ecosystem. There are a lot of tools and frameworks that you can use with Node. I'll go over some of those soon. Node is pretty popular with startups as well as large companies. And the biggest reason for me why I like Node.js is because I like JavaScript and I like to have the same language on both the front end and back end. So if I'm using React on the front end, it's nice to be able to use the same language on the back end as well. Now, Python is another popular option. It's a general purpose programming language that's used for a lot of different things. In fact, I'd say Python's probably one of or the most diverse languages out there. It's great for data science, machine learning, automation, but it's also great for web development, whether full stack applications or APIs and microservices. And Python has great readability. It's relatively easy to learn. There's some phenomenal frameworks that Python offers, such as Django and Flask. I'll talk about those soon. And Python is great for beginners. It's, like I said, very readable. It's easy to get into. Also, at some point, if you want to transition from web development to something like data science, Python is a great option. It's just a fantastic general purpose language overall. Next, we have PHP, which is a server-side scripting language designed for web development. So unlike Python, where you can use it for a lot of different things, PHP isn't really used outside of web development, at least on a large scale. And its purpose is to build dynamic web pages. So there's some popular platforms that use PHP, such as WordPress. I think PHP is great for freelancers because, again, it's a tool that allows you to get things done quickly. And it's unique from other languages because you can actually go to a PHP page in the browser and load the page on the server, and you can write HTML directly in your PHP files. So it's essentially a template language, and you can't really do that with any other languages. The downside to PHP is that you get so much freedom that it's really easy to write bad code, and I think that's why PHP does get a bad rap sometimes. But if you know what you're doing, you can write clean code with PHP, and frameworks like Laravel address that and pretty much don't allow you to write bad code or really bad code. So it's definitely a good choice in my opinion. Now, Go or Golang is a statically typed language developed by Google, and it's known for its performance and efficiency, which makes it suitable for building web services, APIs, and powerful applications. It's also great for building things like command line tools. It's a fairly new language, but it's growing in popularity. It's among the top 10 primary languages for professional developers with a share of about 7%. And it's used by some really big companies and power some really huge applications and APIs. It's not really something you'd use for like a personal blog. It's more for large-scale applications. One thing about Golang is it has a very vast standard library, so you can build quite a bit without reaching for any kind of framework. However, there are some great frameworks that you can use with Go, and I'll talk about those soon. It's also a very secure language. It scales well, making it suitable for large-scale applications. And it's used a lot in the big business world. So C# is also a general-purpose language. It's a robust object-oriented language developed by Microsoft. It's used for building desktop applications, web apps, mobile apps, games, and more. And it's a very popular language and used by a lot of companies. It's also used for game development with Unity. It's a great language to learn, and it's very similar to Java, but better in my opinion. It's also used with the .NET framework, which is a software framework developed by Microsoft that's very, very powerful and can be used with many different types of projects. Then you have ASP.NET, which is a web framework for building web applications, very similar to something like Django or Laravel. But it's a great language. It has good performance. It's very secure and definitely a candidate. So Java is another general purpose object-oriented language that's actually really similar to C#. Java is used for, again, desktop apps, Android apps, backend web development, and more. And it's been around for a really long time, and it's most popular in the enterprise world. It's used by a lot of big companies. One stack that I see a lot of in big business is Java or C# on the back end and Angular on the front end. So I may get some crap for this, but I think Java is one of the best languages to learn programming in general. It's very strict and it forces you to write clean code in an object-oriented way. It was actually the first language that I've ever worked with, so I may be a little biased on that. I wouldn't use it for freelancing or small projects, but if you're looking to get into a big company, it may be worth learning. So Ruby is a dynamic object-oriented programming language that can be used for web applications and APIs, among other things. Its most popular web framework is Ruby on Rails, and it's tough to talk about Ruby without talking about Ruby on Rails in the context of web development. As far as the language goes, I really like it. I think it's one of the most readable languages there is. And it's almost like reading English, and that was actually one of the goals of Mats, the creator of Ruby. And it's a pretty forgiving language as well. It's not a C syntax language, and it has its own unique and expressive syntax. It does draw inspiration from languages like Perl, Smalltalk, and Lisp, all of which I've never used. To me, I think it actually is similar to Python. Ruby has a rich ecosystem of open source libraries and packages called gems, which can be easily integrated into Ruby on Rails projects to extend the functionality. So gems, Ruby gems, it's kind of like NPM if you're coming from the Node.js world, or pip if you're coming from Python. And you can get things up and running really, really quickly with Ruby. It's great for rapid development. People like to say that Ruby is dead. Sure, it's not as common as some other languages, and it has fell a bit in the past 10 years, but there's still a lot of companies using it. Now, Rust is actually a systems programming language, so it's lower level. It can almost relate to something like C++, but it also incorporates high-level language features, so it's pretty unique. And you don't have to worry about things like memory management like you would with C or C++. Rust isn't typically associated with web development, but it does have features that can make it a good choice in certain situations. Now, Rust is a popular choice for compiling to WebAssembly, enabling the development of high-performance web apps that can run in the browser, and I'm going to talk more about WebAssembly later. It's also a very safe language. It's used by companies like Dropbox, Discord, Microsoft. Web development probably isn't the most common case for Rust, but it's still a great language to learn. I think it will grow more popular in web development because it's commonly used with WebAssembly. So as WebAssembly gets more popular, I think Rust will as well. There's also web frameworks that you can use that I'll mention in a little bit. So Elixir is new to this guide and it's been gaining some popularity. I've seen quite a bit about it. It's a functional concurrent general-based or general-purpose language and runs on the Erlang virtual machine. And it can be used to build web applications and APIs. It's very fault tolerant and can be used to create real-time applications. Like I said with Golang, you probably won't use Elixir for something like a personal blog or any small project. It's more for large-scale applications, so not something I'd recommend if you're just getting into web development. Now, these definitely aren't all the languages you have to choose from. Some other options are Scala, Perl, Swift, and Kotlin, although those are really more for mobile apps. Sorry, I would suggest looking into a few and seeing which ones you like best. Also, look at what's popular in your area. So this is a chart from JetBrains.com for 2017 to 2023, and it's the percentages for languages used by web developers and the percentages for likely to adopt. So you can see that the most used is JavaScript, then Python, HTML, CSS, SQL, Java, and so on. So I wouldn't base everything on this chart, but it's just interesting to see. And you can pause it if you want. I'll also have the link in the description to this article. So now that we've gone over some server-side languages, let's talk about some of the frameworks that you can use with those languages. And I'm not going to go over all of them. There's no way I could do that, but I'll list some of the more popular ones here. Now, most of these frameworks fit into either an opinionated or an unopinionated framework. So an opinionated framework is one that has a set way of doing things. It's very high level and abstract. You kind of have to follow the structure and follow the rules to use it. However, you get a ton of features right out of the box. An unopinionated framework is one that's usually more minimalist and gives you more freedom, but doesn't give you as many features. So there's pros and cons to both. The downside to a minimal framework is obviously you don't get as much, but the downside to an opinionated framework is you don't have as much freedom. So what I've done is I've split the frameworks that I'm going to mention up into opinionated / high level and unopinionated / minimal. All right, and we'll go in the same order as we went with the languages. So Node.js, I should say JavaScript / Node.js, has a bunch of frameworks. There's way too many to list here. So these are some of the more popular ones. Now, unlike the rest of these languages, the most popular framework for Node.js is actually a very minimal, unopinionated framework, and that's Express. So Express is great for building web applications and APIs. It has a great set of features. It's well documented. It's very popular. You can find tons of content and tutorials and courses that use Express. There's a great community. It's very fast and performant. So that's probably what I would recommend if you're going with Node.js. Then you have Koa, which is another minimal framework that was actually created by the same team as Express, and it's very similar. There's some more modern features, but it's pretty much the same thing. You can build a lot of the same stuff. And same thing with Fastify. Fastify is an even newer framework that is extremely fast. It's faster than Express and, again, has some more modern features. But again, I'd probably say learn Express just because it's so popular, and that's probably what you'll end up using. All right, so those are the popular unopinionated or minimal frameworks. As far as the high-level opinionated frameworks, we have Nest or Nest.js, which is actually built on top of Express, and it's a TypeScript-first framework that's very similar to Angular. And I know that sounds weird because Angular is a front-end framework, but it actually has a really similar structure. Now, it's very opinionated, and you have to do things a certain way, but it's great for building large-scale applications. It's very well documented. I'd say if you're coming from Angular and you're learning full stack and you're getting into Node.js, you might want to check Nest.js out for your backend. And then Adonis is the last Node.js framework that I'll mention. It's another very opinionated framework that's very similar to Laravel. I actually think that it's really underrated. It's an MVC framework that has scaffolding, authentication, a template engine. It has a lot of the features that you find with Laravel. So if you're coming from PHP Laravel to Node.js, Adonis might be something you want to check out. All right, so next we have Python, and there's a lot of frameworks that you can use with Python, but there's two that really stick out that are really phenomenal frameworks, and that's Django and Flask. And one of them is high-level opinionated, and one of them is minimal and unopinionated. So Django is very high-level. It includes everything that you need to build a web application. It has a template engine, an ORM, authentication, a CLI. Like I said, it's very opinionated, so you have to do things a certain way, but you also get a ton out of the box, including an entire admin area to manage your content. So basically, you can create models for your content, like let's say a blog, and you have a post model. You'll have an admin area just right out of the box where you can add, create, read, update, and delete posts. So really, really cool. It's great for freelancers as well because you have an admin area for your clients. And then Flask is another great Python framework that's pretty much the polar opposite of Django. Flask is very minimal. It's very similar to Express. It's great for building APIs. You can structure things how you want. It's fast. It's flexible. It's a great option. So next we have PHP, and the two most popular frameworks are Laravel and Symfony. And there's others like CodeIgniter, which was actually my first PHP, or I should say my first MVC framework that I was introduced to, and I really like it. It's not used much anymore, but I don't know, CodeIgniter has a special place in my heart, I guess. But Laravel is, in my opinion, one of the best frameworks, period. It's a high-level opinionated framework. It includes everything you need to build a web app. It has database migrations, has a really great ORM called Eloquent, and I'll get into ORMs in a little bit. Built-in authentication with multiple drivers, a CLI, a template engine, and much more. I'd say it's pretty similar to Python's Django. Then you have Symfony, which is another great PHP framework. It's a bit more complex than Laravel, and it's used by a lot of big companies. Laravel is actually built on top of Symfony components because Symfony is very modular. I created a small course on Symfony a long time ago, but I haven't used it in years, so a lot of it has kind of slipped my mind. But it might be something you want to check out. Now, Slim PHP is another framework that I think is really underrated because you don't always need something as large as Laravel or Symfony. Sometimes you just need a simple framework to build an API or a small application, and Slim is great for that. It's very similar to both Express and Flask, but for PHP. So next we have Golang. One thing that I realized is with just about every language, you need a web framework to build anything substantial. With Golang, you really don't need a framework. You can just use a lot from the standard library. So it's very powerful. It has everything you need to build a web application. But there are some frameworks. So one is called Gin. This is an unopinioned framework. It's known for its minimalistic design, high performance, and ease of use. Gin includes built-in support for JSON and XML, making it a good choice for APIs and for mobile or web applications. And then Echo is another lightweight and performant framework, which features routing, middleware, context support. And if you want something more robust, Iris is a full-featured framework that includes a router, template engine, and more, and it's more like Laravel or Django. So next we have C#, and C# is a general purpose language that is used for all kinds of things, web development, mobile development, game development, and it's used a lot with the .NET framework, which is a software framework developed by Microsoft. Then you have ASP.NET, which is a web framework for building web applications. So ASP.NET is probably what you're going to use if you do go into web development as a C# developer. It's part of the broader .NET ecosystem, and it provides a flexible platform for developing web-based applications. You can also use languages like F# and Visual Basic with ASP.NET. So ASP.NET Core is the latest version of ASP.NET, and it's open source, it's cross-platform, it's a bit more lightweight than the original platform. But yeah, so that's probably what you're going to go with C#. Now, you also have Blazor, which is a newer framework that actually fits more into a front-end framework, believe it or not. So it's part of ASP.NET Core, and it allows you to build interactive web UIs using C# instead of JavaScript. So in many ways, it's similar to something like React or Vue, and it can also be used with WebAssembly, which I'll talk about soon. So next we have Java. The big web framework for Java is Spring, and it's used by a lot of big companies. It's a bit more complex than some of the other frameworks, and it has a lot of different parts to it. So Spring MVC is a web framework that simplifies the development of web applications and follows the model view controller design pattern. And it provides features for building web controllers, handling requests, and rendering views. There are some other web frameworks for Java like Hibernate, Apache Struts, and Play, which you can also, the Play framework, you can also use with the Scala programming language. Now, if you're using Ruby for web development, I'd say there's probably a 99% chance you're going to be using Ruby on Rails. It's a very high-level, opinionated framework that just includes a ton of stuff out of the box. And it's great for rapid development because you basically have command line tools and scaffolding that can pretty much generate a basic CRUD application in seconds. And then you can kind of take it from there. So it's great for large scale applications, but you can also use it for smaller stuff. I actually had a knowledge base app that I built with Ruby on Rails that served as documentation for my computer repair business a long time ago. Rails is definitely, I'd say, in my top 5, if not top 3 favorite frameworks. And then Sinatra is another framework that uses Ruby that takes a more minimalistic approach. So if you don't need something as in-depth as Rails, you could check out Sinatra. Now, Rust is often associated with systems programming, but it has gained popularity for web development due to its focus on safety, performance, modern programming practices. While Rust doesn't have as many web frameworks as some other languages, it does offer some solid options for building web applications and APIs. So Actix is a high-performance web framework for Rust. It's known for speed and scalability, makes it suitable for real-time applications, microservices. Actix leverages Rust concurrency features, and it can be a good choice to handle many connections simultaneously. And then Rocket is an opinionated web framework for Rust that prioritizes developer productivity. So it aims to create kind of a great out-of-the-box experience with strong type checking, expressive syntax, and a focus on safety. Now, for Elixir, you have Phoenix, which is a framework that's inspired by Ruby on Rails. It's a high-level opinionated framework, includes everything you need to build a web application. It's great for building large-scale applications, but you can also use it for smaller projects. And again, it's very similar to Ruby on Rails. And then Plug is a minimal and composable library for building web apps in Elixir. It's designed to be lightweight and unobtrusive. All right, so I mean, there's other frameworks as well, but chances are if you're going with one of these languages, you're probably going to use one of these frameworks. All right, so you learn a language, you learn a framework. At this point, you should understand HTTP, including the request response cycle, methods, status codes. You should also understand the basics of REST, which stands for Representational State Transfer. And it's an architectural style for building APIs. It's not a standard or protocol. It's just a set of guidelines for building APIs. And I have an older but still relevant crash course on REST APIs if you want to check that out and learn more about what it is. No matter which type of developer you are, you should definitely understand REST, because even as a front-end developer, you're going to interact with these APIs. And as a back-end or full-stack developer, you'll be building these APIs. So something that you just need to know in web development. Now, GraphQL is a newer alternative to REST, and it's a query language for APIs and a runtime for fulfilling those queries with your existing data. It's a bit more complex than REST, and I wouldn't say that GraphQL is something that you absolutely need to know, but it is helpful. It's a little bit more powerful because you can specify the data that you want to get back from the server, where with REST, you get all of the data that's available. So for instance, if you have a REST endpoint that you hit, maybe /API/posts, it's going to give you all the fields for posts. You know, you might get back 10 blog posts. It's going to have the title, the body, all that stuff. And you can't really say, well, I just want the title of the post. You can't do that with a REST API. With GraphQL, you can. You can actually send a query that says, I want just the title and the category or whatever it might be. So it's more powerful than a REST API. But again, it's not a necessity. As a back-end or full-stack dev, you may be creating GraphQL APIs, and you can do that with many different languages and frameworks. And as a front-end dev, you may be interacting with these APIs. So you'll learn how to make GraphQL requests and parse the data using a client. There's different GraphQL clients, and one popular one is Apollo. Okay, so if you're a front-end dev dealing with GraphQL, there's a good chance you might be using the Apollo client. Now, as a back-end or full-stack dev, or even as a freelancer that works with WordPress, you're going to need to learn about databases. And a database is a collection of data that's stored in a computer system. And the software that we use to work with that database is called the Database Management System, or DBMS. And there's a few different types of databases. So I just want to go over those real quick and talk about some of the database systems that are in those types. So the first type is the most common, and that's a relational database. And these have been around forever. They're systems that hold structured data that can be related to each other. And data is stored in tables and rows. So you can kind of picture an Excel spreadsheet, just much more powerful. And you can have multiple tables that are related to each other. For example, you can have a table for your users and then a table for, let's say, blog posts. And each user can have multiple blog posts, so you can relate the two tables together by putting a user ID field in your blog post table. And we use something called SQL or SQL, which stands for Structured Query Language. We use that to interact with these databases. So you can create tables, insert data, update, delete data, and more, aggregate data. And usually in your application, you'll use something called an ORM, or an Object Relational Mapper, to interact with your database instead of writing raw SQL queries. And we'll talk more about ORMs in a few minutes. Now, as far as relational databases go, Postgres, or PostgreSQL, is one of the most popular for all size projects, really. It's an object relational database, so everything is looked at as an object with properties. And it's very common with Node.js and Python, but of course you can use it with any language as long as there's a driver that supports it. So you're not really bound to a specific database system just by the language you use, but some things are just more popular with others. So MySQL, or MySQL, is very similar to Postgres. They work in a very similar way, and MySQL is very popular in the world of PHP. So if you're learning PHP and you're learning with content online, tutorials, courses, chances are a lot of them are going to be using MySQL. And then MS SQL, or Microsoft SQL, is used a lot with like C# and the .NET framework because it's part of that whole Microsoft ecosystem. But you can still use like Postgres with C#, so you're not bound to any specific system as long as there's a driver available for it. Now, you also have NoSQL databases. These are non-relational databases which store data a bit differently. I'd say they're more for huge data sets that aren't as closely related. So you can still have relationships, but you don't get as many features as you do with relational databases in that aspect. And what these are typically good for is performance and scalability. They're also great for things like real-time web applications. You also have a subset of NoSQL databases like document databases or key value stores. So instead of storing data in tables and rows with columns, you store data in what are called documents in something called a collection. You can kind of think of a collection as a table and a document as a row or a record in a relational database. And documents are formatted like JSON objects, so it really goes well with JavaScript. In fact, MongoDB, which is the most common NoSQL database, is used a lot with Node.js. Now, some other NoSQL databases include Redis, which is a key value store. It's great for caching and storing session data. It's also very fast. Then you have Cassandra, which is a wide column store. It's great for large-scale applications. Neo4j, which is actually a graph database, but still considered NoSQL. It's great for storing relationships between data. So if you have a social network, for instance, you can use Neo4j to store the relationships between users or whatever. You also have CouchDB, DynamoDB. There's tons of NoSQL databases, but I would say MongoDB is the most popular by far. Now, cloud databases are extremely popular now, and it used to be that you would install the database on your server and set everything up yourself, but now you can use a cloud service like AWS or MongoDB Atlas where your database is hosted separately. So this is great for scaling and performance. You can use a lot of the ones we talked about. For instance, you can set up a remote Postgres database through Amazon Web Services or a MongoDB database through Atlas. But there's other cloud databases such as Google's Firebase, which is a real-time database, and it includes everything you need from authentication to file storage to hosting. And it's an all-in-one solution for medium and for small and medium-sized apps. And then Supabase is another one that's similar to Firebase. It's an open source alternative that's built on top of Postgres. And it's a great option if you want to host your own database, but you want the features of something like Firebase because it also includes authentication and stuff like that. So I prefer to use databases hosted in the cloud because it just takes so much work out of it. You don't have to worry about backups or anything like that. You don't have to worry about getting it set up. You have full support in most cases. As long as, you usually have to be on a paid plan. MongoDB Atlas does offer a free tier, but if you have a serious project, you're going to want a paid plan. All right, so it just lets you focus on your application and not have to worry about the database aspect of it. And then FaunaDB is another one that's starting to gain a lot of traction. It's a serverless database that is used a lot in the JavaScript world, and it has a TypeScript-inspired developer experience with data stored in documents similar to MongoDB. So lastly, we have file-based databases. Well, Markdown actually isn't a database, but I'll explain in a minute. So these have little to no setup, and they're great for developing, they're great for testing, and for just small projects, even if you want to use it in production for like a personal blog or something like that. So SQLite or SQLite, it actually is a SQL database, but it's file-based, so you don't have to install anything or anything like that. You just create a file, something.db, and you can just use SQL queries. And there's ORMs you can use with it as well. So I think it's great for, of course, just development. If you don't want to set up a Postgres database or something like that, and you just want to temporarily use SQLite, or if you just have like a simple blog and you're not going to have a ton of data, you just create a post every couple of days, SQLite is more than enough for something like that. Now, Markdown files are also good for personal websites, for personal blogs, things like that, especially if you're using something like Gatsby or Next.js. There's packages that you can use to work with Markdown files. So when you want to create a new blog post, you would simply create a new Markdown file in a specific folder, and you would add the front matter, which is the metadata at the top, and then the post in the body. And once you save that, it'll automatically be put into your blog's front end. So definitely something to look into for smaller projects. And then H2 is another file-based database. I've never used it, so I really can't say much about it. I would stick to SQLite or Markdown for development, testing, as well as small projects if you don't want to install or set up Postgres or MongoDB or something like that. Okay, so like I said, SQL or SQL is used to create queries, to insert data, select data, all that stuff for relational databases. But typically you don't write SQL queries, raw SQL queries in your application code. It's more for the command line if you're using like the MySQL shell or something like that, or if you're using even a GUI tool, you can usually write SQL queries. Within your application, you're usually going to use an ORM, which stands for Object Relational Mapping. And it's a tool so you can interact with your database through object-oriented programming within your application. And it usually has its own syntax like I said, rather than writing SQL queries. And it's great for productivity. It makes your code much neater. They tend to prevent things like SQL injection attacks. And a lot of the time, you can easily swap out database systems and still use the same code. So even if you use Postgres and you want to switch to MySQL, you can do that just by changing a config and then keep the same code and it still works the same way. So typically how they work is you create a model of your data in your application. So you might have, let's say you have a workout app and you have a database table or a collection called workouts. In your application, you would create a model for workouts and you would define the different fields and types that the workouts should have. And then what you would do is bring that workout model into your file, and you'll be able to do things like workout.find and then pass in whatever you're looking for, a workout with the ID of a certain number or whatever it might be. Much better than writing select all from workouts, where, whatever. So it makes things much easier. And some ORMs are specific to the language and or database. So these are just some examples. First, we have Mongoose, which is an ORM for MongoDB and Node.js. So if you're using those two things together, Node.js and Mongo, there's a good chance you're going to be using Mongoose. Sequelize is also an ORM for Node.js, but it supports SQL databases like Postgres, MySQL, even SQLite, and MS SQL Server as well. And it's very popular and easy to use. It's very well documented. And then Django ORM is used for, obviously, Django websites, but you can use it as a standalone ORM without using Django as well. SQL Alchemy is an ORM for Python that supports the same databases that Sequelize does, and it basically works the same way, except it's for Python, and you can use it with Django, Flask, or any other Python framework. And PyMongo, I don't know if I said this, but most of these are for relational databases, except for Mongoose, and then you also have PyMongo, which is an ORM for MongoDB and Python. So similar to how Mongoose is to Node.js. Then Eloquent is an ORM for PHP that's used with Laravel. And I really like Eloquent. I think it's very eloquent and it's very easy to use. It has a very clean syntax, well documented. Doctrine is another ORM for PHP that supports SQL databases. Dapper is an ORM for C# and .NET, very popular, used by a lot of big companies. Prisma is a TypeScript ORM with an intuitive data model. It has automated migrations, type safety. It lets you declare your database tables in a more human-readable way. And you can use it with JavaScript, TypeScript, Rust, and I believe you can use it with Golang. So Drizzle ORM is another TypeScript ORM that you can use in SQL-like syntax, or the Queries API, which is a more Sequelize or Mongoose-like syntax. And then Micro or Micro ORM, I'm not sure how it's pronounced. I've never used this, but it's another TypeScript ORM that supports both MongoDB as well as SQL databases. And then Next.js is a query builder for Node.js that supports SQL databases. It's not an ORM, but it is similar. It's a bit more low level, and it's great for building SQL queries in a programmatic way. So you can imagine how many of these are when you think of how many languages and how many databases there are. So there's no way I can go over all of them, but I just wanted to give you guys a couple examples. All right, so another thing you'll need to learn pretty much no matter what route you take is authentication and authorization. So authentication is the process of verifying the identity of a user. It's a very important part of web development. As a front-end dev, you need to know how to consume and use authentication services. And as a back-end or full-stack dev, you're most likely going to need to know how to implement the entire system. And there's a few different ways to do this. These aren't all of them, but these are some very common practices. So one, we have cookies and sessions. This is a popular way to authenticate. Basically, when a user logs in, a session is created on the server and a cookie is created on the client. And the cookie is sent with each request, and then the server can verify that user based on the session. So you should definitely learn about HTTP-only cookies and secure cookies. This will help you understand how to make your application more secure. Also, you're going to want to be aware of things like cross-site scripting and cross-site request forgeries. These are attacks that can be used to steal cookies and impersonate users. Next, we have JSON Web Tokens, or JWTs, and these are JSON objects that are signed by the server, and they're stored on the client in most cases and sent with each request. And the server can verify the user based on that token. And this is commonly used with REST APIs and full stack JavaScript applications. And it's a good way to protect your API endpoints so that not just anybody can visit every endpoint. Then we have OAuth, which is an open standard for access delegation, and it's commonly used as a way for users to grant websites or applications access to their information on other websites, but without giving them passwords. So for example, when you see log in with your Google account or log in with your Facebook account, that's usually OAuth. So that's another way that you can have users authenticate. And you might have a mix of OAuth and cookies and sessions or something like that. Now, authentication libraries, you can write your own middleware for authentication, but there's a bunch of libraries you can use, such as Passport or Grant. Also, many frameworks such as Laravel and Django, they have built-in authentication systems that you can use and extend. And then password hashing, that's also something you're going to need to look into. There's libraries like bcrypt that can do this for you, and it'll encrypt the password. You never want to save plain text passwords in your database, and then you can use the bcrypt library to compare a plain text password to the encrypted one in your database. Now, traditionally, we have front end and back end, but as I've said, those lines are really getting blurred, and serverless architecture is becoming more popular. Now, serverless is essentially, it allows you to run server-side code without having to manage your own server. So you can use a platform like Netlify or Vercel that will give you serverless functions. You could also use something like AWS Lambda or Azure Functions. Platforms like Firebase and Supabase also considered serverless. You can use serverless functions to handle things like authentication, sending emails, protecting data, and it also saves you money because you're not paying for an all-the-time server, a server that's always running. You're only paying for the time that your code is running and hits those functions. Okay, it's event-driven, and your code is triggered by events like HTTP requests, file uploads, or database changes. So if you have a small application, this is a great option. Serverless architecture is usually really scalable as well. It's also part of what we call the Jamstack, which is a modern web development architecture based on client-side JavaScript, reusable APIs, and pre-built markup. Okay, so it's a great option for static websites and small applications. Most of the technologies that are included in the Jamstack we've already talked about. So that would be static site generators like Gatsby and Next.js, APIs like GraphQL and REST, and then serverless functions. So it's not really anything new, it's just a new way of doing things. So to learn more, you can check out the Jamstack website. James Quick also has a great crash course on this channel about what the Jamstack is, if you want to check that out. Now let's talk about deploying full stack applications and APIs. This is a bit more difficult than deploying a client-side application or like a static website, because you typically need a web server like Apache or Nginx, and there can be a lot of configuration that goes into that. Now, how you set that up depends on the type of hosting service that you're using. You can use something called a platform as a service, or a PaaS, and then you also have infrastructure as a service, or an IaaS. So a PaaS, or a platform as a service, abstracts away the server and sometimes the database, and you can just deploy your code. You usually have a pretty in-depth user interface, and you have access to the server through a terminal, but you don't have to install and configure like Apache and all that stuff. And this is obviously easier and great for people that aren't too familiar with Linux and running servers. Then you have cloud hosting and infrastructure as a service, and this is where you have to manually set up and configure your server. You have full control over everything. That's the nice part about this. You can install and configure Apache, you can install a database, whatever you want. It's basically like having your own Linux machine with root access. And again, it's great for people that know what they're doing, but a lot of us don't, right? I really am not that great with DevOps. I'm not great with setting up servers, so I prefer to use a platform as a service. But there are some great infrastructure as a service hosting companies like DigitalOcean, Linode, and then you have, like, of course, AWS and Azure, which are the big boys. Really large companies tend to use them if they don't have their own infrastructure. But we're starting to get into DevOps territory here, which is a whole nother topic. But I just want to mention that there are different types of hosting, and it depends on what you're building and your skill level as to what you should use. And I should say that cloud hosting like DigitalOcean and Linode, I'd say they're semi-managed, because they do have images you can use to set up an entire environment for you. You can even set up Docker, and I'll talk more about Docker in a little bit. But you can have some predefined infrastructure with DigitalOcean or Linode or Vultr. There's a lot of companies that do that. Now, for individual developers, I suggest Render if it fits your need. It's great for Node.js, Python, PHP, Rails, and a bunch of other stuff. It's very easy to use. It's free for personal projects. You can also deploy databases and static sites. Heroku is another option. It's been around for a while. It used to be what I used in tutorials because they had a great free tier so people could follow along. However, they did get rid of the free tier. So if you're just learning and testing things out, you'll probably want to go with Render because they do have a pretty generous free tier. And all you really have to do is deploy to or push to GitHub and then log into Render and select your repo, much like you would with Netlify or Vercel. And Render does support full stack applications. All right, so I briefly mentioned Bun.js, but I wanted to have a dedicated section for it because it's another one of my favorite new technologies that I really hope takes off. And I have a crash course on it if you want to go more in depth, but it's essentially a JavaScript runtime like Node.js, but it also has a complete toolkit that includes a front-end bundler so you can easily build full-stack applications. It has a test runner. It has its own Node.js compatible package manager so you can run bun install whatever package you want. It's written in the Zig programming language, which is a newer language that's gaining some traction. It's very fast. It's similar to C. But what I love about Bun.js is that it's an all-in-one approach, and you don't have to use Webpack or Parcel or anything like that. It's all just built in. I think that JavaScript's biggest problem is there's just so many different damn things that you need to combine and use. Other languages aren't really like this. If you have any experience with other languages, they have a very integrated, close-knit ecosystem where JavaScript is just all over the place. So I think that Bun really addresses this, and it's still very new, and it's not really ready for production yet. At least I don't think. I haven't checked in a little while. But I think it will be soon. I'm hoping that it will gain a lot of traction. All right, so up to this point, we've talked about everything that you need to know, plus a lot of optional things to be a back-end or full-stack developer. So obviously, you need to know a server-side language. Which one you choose is really up to you. If you're building web apps or APIs, you'll need to know a framework. It's very rare to create a substantial application without a web framework. There are some exceptions, like if you're using a language like Golang or Rust, but even then, there are frameworks that you can use. Now, you'll need to know about databases. This could be a relational or a non-relational database. You also need to know about ORMs, so you can create models for your data and interact with your database. And this could be a standalone ORM or one that's built into your framework. And then authentication, you should know how to implement in your applications. This is a very important part of web development, whether you're using sessions, JWT, OAuth, or something else, or a combination. And then you should know how to create REST APIs from scratch. You should know how to create endpoints and handle HTTP requests. Knowing GraphQL is also a plus, but I don't think it's mandatory. You also need to know how to make your applications or APIs live on the internet. So you'll need to know deployment. And again, this is more difficult than client-side stuff, but you'll establish a process and it'll start to become second nature once you have a workflow to deploy applications. So the next batch of technologies are things that you may want to get into, but I wouldn't say are essential to becoming a developer. They're kind of extra. They may be essential for certain job positions, though. So the first one we'll look at is containerization. And this is a way to package software into standardized units for development, shipment, and deployment. And some people don't understand why this is valuable. So let's say that you're working on a Node.js application and you have it running on your local machine, everything's working fine, then you deploy it to a server and it doesn't work. Or you give it to another, a coworker, another developer, and it doesn't work on their machine, and you have to figure out why. So it could be that the server is running a different version of Node.js, or maybe it's running a different operating system and something got messed up. Now imagine you have 5 people, 10 people working on that project, all having different machines and different operating systems and environments. So that can be a nightmare. And with containerization, you can package your application into a container that includes everything it needs to run, It's kind of like a virtual machine, but it's much more lightweight. And you can then deploy that container to any server and it will run the same way. So all 5 or 10 plus team members can have the same container on their local machine and it will run the same way. It's a great way to ensure that your application will run regardless of the environment because it includes the environment, everything down to the operating system. So Docker is the main tool that's used for containerization. It's a platform for building, running, and shipping applications with containers. It's very popular and used by a lot of big companies. It's also very well documented. If you plan on working for a large company, as anything that has to do with DevOps, then you're going to need to know Docker. And then Kubernetes is another tool that's used for containerization. It's an orchestration system for automating deployment, scaling, and management. And it's not a competitor to Docker. It's actually used with Docker, and it allows you to manage multiple containers across multiple servers. All right, and AI-driven automation is also enhancing the capability of Kubernetes, and the complexity is being kind of abstracted away more and more, and developers will be able to focus on application development and much less on infrastructure management. And there's some other tools that you can use that are similar to Docker, like Vagrant and LXC, but these are more like virtual machines. Docker uses containers, which are process level virtualization, so they're much more lightweight. So next we have WebAssembly, often abbreviated as WASM, and this is a technology that allows us to run high-performance code written in languages like C, C++, and Rust in web browsers. And in simple terms, think of WebAssembly as a way to bring fast and efficient software written in languages other than JavaScript to your browser. And JavaScript has obviously been the programming language of the browser and just for the web in general, and is great for many things, most things when it comes to web development. However, it's not good for things like computationally intensive tasks. So WebAssembly is great for that, and you can port existing code bases to the web. So if you have like a C++ application, you can compile it to WebAssembly and then run it in the browser. So some things that WebAssembly would be good for are games, video editing, CAD software, things like that. And no, WebAssembly will not replace JavaScript. It's not meant to. It's actually meant to work with JavaScript. So you can use JavaScript to interact with WebAssembly. And we're really not to the point where WebAssembly is just everywhere, but it seems to rise every year. It seems to gain more popularity. Now, next we have mobile development options, and I know this is a web development guide. However, there is a lot of crossover, and you can use your web development skills to build mobile applications. Of course, you can get into native development, mobile development with Kotlin or Java for Android apps, as well as Swift or Objective-C for iOS apps. But you could also use frameworks that allow you to build cross-platform applications with web or web-like technologies. So I'm going to go over some of those options. Now, we did already talk about some of the stuff in the framework ecosystem section, but I'm just going to quickly go over them again. So the first choice is React Native, and obviously we've talked about this a little bit. It's a framework that allows you to build native mobile applications with JavaScript and the React framework. And what's great about not only React Native, but all of these really, are that you can have a single code base for both iOS and Android, as opposed to where you would do native development, you'd have to have two separate code bases and two separate languages. So if you're a React developer, you're probably going to gravitate toward React Native. It's very powerful. It's used by a lot of big companies. Next, we have Flutter, which is another popular option, and it's a framework that allows you to build native mobile apps with Dart. So Dart we haven't talked about yet. It's a programming language that's similar to JavaScript. So if you already know JavaScript, Dart is pretty easy to pick up. Flutter uses its own rendering engine written in C++ called Skia, and I know that they were working on a new rendering engine called Impeller, but I'm not positive if that's been released yet. Now, Flutter does have a slight performance advantage over React Native because it doesn't use a bridge to communicate with the native components like React Native does, but these are two of the most popular options of their kind. Now, you also have NativeScript, which allows you to access native APIs using JavaScript. So you can technically use any framework you want to build native mobile apps, whether it's React, Vue, Svelte, Angular, or even just vanilla JavaScript. So like I said, it gives you a set of native APIs to work with. It's not as popular as React Native or Flutter, but it could be a viable option, especially if you want to stick to Vue or Svelte or Angular. And then you also have Ionic, which has been around for a while. It's a mobile SDK, software development kit, that allows you to build hybrid mobile applications with web technologies like HTML, CSS, and JavaScript. So you can also use the framework of your choice with Ionic. Now, it's not going to be as fast as React Native or Flutter, but it can be a viable option. I believe years ago you could only use Angular, but now you can use anything. And it's great for progressive web apps, which I'm going to talk about next. So progressive web apps are web applications that have been designed to run more like native mobile applications. They're fast, they work offline, they can send push notifications, they can even be installed on the home screen of your mobile device. So it's not a native app, it's a web app, but it has to pass certain criteria to be considered a PWA, or a progressive web app. So first, it has to be completely responsive no matter what screen size, no matter what type of device it's being viewed on, whether it's a cell phone or a big screen TV. It also has to be secure and served over HTTPS. That should go without saying these days. It has to be able to at least have some basic functionality offline, even if that means just having a custom offline page. It should be performant and discoverable by search engines, and include a manifest file and a service worker. So the manifest file is a JSON file that contains information about the app, like the name, description, icon. The service worker is a JavaScript file that runs in the background and allows you to cache assets and data for offline use. Okay, then you can also add push notifications, make it installable. So it's a great way to make your application more like a native mobile app than a regular web app. And you can use a framework like Ionic, or you can use something like Next.js, which has built-in support for PWAs. There's many different technologies and different ways to do it. Now, you can also use a lot of the same technologies that you use for web development to create desktop applications for Windows, Mac, and Linux. Now, my suggestion would be Electron. It allows you to use JavaScript to build really fast and powerful desktop applications. You can use any front-end framework, React, Vue, Angular, whatever you want to use. It works by bundling Chromium, which is the browser engine that Chrome uses, that Edge uses, and a bunch of other browsers. It bundles that with node.js into a single runtime, and apps can be packaged for Mac, Windows, and Linux. So you have, again, a single code base for all three platforms. And there's a ton of really popular desktop applications that use Electron, at least in some way, including VS Code, which is probably the desktop app that we use the most, Atom, Slack, Discord, and the Postman HTTP client. So these are all things that I use all the time. Another option that I'm seeing more of is Tori. And this is a newer framework that's similar to Electron, but it's actually more lightweight. And it's actually built on Rust. So it's very performant and secure. It uses the OS's native web renderer, and the size of a Tori app can be less than 600 kilobytes. And you can use front-end frameworks, of course. There's also binding for Python, Go, C++, and other languages. So it's definitely something that I plan on getting into this year. So next we have Neutralino.js, and this is another option. It's a lightweight and portable framework that allows you to build cross-platform desktop apps with web technologies. And it implements a secure WebSocket connection for native operations, and it embeds a static web server to serve the web content within the desktop application. Also, it offers a built-in JavaScript client library for developers. Now, NW.js is another option. It's similar to Electron, but not as popular. It works in a similar way by bundling Chromium with Node. I do have a crash course on NW as well as Electron if you're interested. I would say go with Electron if you're going to get into this kind of thing. And then you have other options for other languages. For instance, if you're a Python developer, you can look into tkinter to build desktop applications. I do have a video on that. It's a standard Python interface to the TK GUI toolkit shipped with Python. It's not as popular as Electron, but it can be an option if you're a Python developer. Kivy, Kivy is another option for Python. And then, of course, you have native, other languages where you can use native tools, whether it's Java, WPF for C#, Cocoa for Swift, whatever it might be. But that starts to get out of the range of web development technologies. All right, so I don't often talk about aesthetics in this guide. It's based on software, but I do think it's important to keep up to date with design trends. So I just want to mention a couple here. So trends for 2024. Dark mode is obviously extremely popular. It has been for a few years. I think it's because it's easier on the eyes, and it's also more energy efficient, and it looks better, in my opinion at least. I personally use dark mode on everything because I actually get floaters in my eyes if I stare at light screens too long. So it's actually a health thing for me. But I know a lot of people like it, and it just seems to be everywhere, whether it's just straight up dark mode or you have some kind of toggler on your UI that will toggle dark and light. And then we have AI generated designs. So I think that we're going to see more of this year. There's all kinds of tools that you can use, such as Midjourney, Sensei, Dream Studio. You can use these tools to create unique designs for your projects. Now, a lot of them do look kind of fake and like super futuristic, and sometimes they look a bit weird, but I think it's a cool concept, and I think it's going to be used more and more as it improves. So glassmorphism is a newer design trend that's become pretty popular. It's a frosted glass effect that is used for many things like buttons, cards, and modals. It's a bit more subtle than the previous trend, which was neumorphism. I don't know how to pronounce it. I think it looks really cool, and I think that it'll be around for a while. And then claymorphism is a web design trend that is characterized by the use of soft, rounded shapes and pastel colors. And this trend is inspired by the look and feel of claymation. It's a popular choice, especially for younger audiences. And then retrofuturism is a design trend that's inspired by the future, and I should say it's inspired by the future as imagined in the past. So like what we used to think the future would look like. And it's characterized by bright colors, geometric shapes, futuristic typography. It's a great option for things like landing pages and portfolios. All right, so I just wanted to throw a little bit of that in there for you guys. All right, so next is IoT, so Internet of Things and the Metaverse. Now, Internet of Things refers to the connection of everyday objects to the Internet and to one another. And it's a very broad term. It's used in many industries, but IoT is expected to have a pretty major impact on web development moving forward. So we can expect to see more IoT-enabled websites and web applications, and this will be, as businesses take advantage of IoT to improve their operations. So it's something that you may want to look into. And then the metaverse is a virtual world where people can interact with each other in a virtual environment. And it's a concept that has been around for a while, but it's really starting to gain traction. So it's something that I think will be a big part of the future of the web. So if this were a trends video, AI would definitely take the top spot. It's something that's being used in many industries, and it's only going to become more popular. So much so that a lot of people are actually terrified. We talked about tools like Copilot and ChatGPT, as well as design generation, but there's many tools in many categories. So chatbots are another thing that are really becoming popular because of AI. A chatbot is a computer program that simulates human conversation through either voice commands or text chats or both. And they're used for things like customer service, marketing, sales. So you can expect to be integrating chatbots into a lot of your applications. And then OpenAI has some amazing APIs that you can use to create your own tools, including tools to create chatbots, text-to-speech, things like that. And there's a lot of AI-powered no-code tools, and I know that scares a lot of developers, but my advice is to use those tools to your advantage to make you a stronger candidate for a job or just a stronger freelancer for clients. And just because those tools are available doesn't mean every Joe Schmo is going to be able to use them or even want to take the time to use them. And I know it's just kind of my speculation, but my overall advice when it comes to AI is to use what is available to better yourself as a developer rather than just saying, poor me, it's going to take my job. Try and use it to make yourself better. That's my advice. I know some people kind of get mad at that. Some people might say I'm naive, but I'd rather have that mind state than the doom and gloom state that is definitely not going to find you success. All right, so DevOps or developer operations is a set of practices that combine software development and IT operations. And it's a pretty broad term. It can mean different things to different people. When you talk about application deployment and maintenance, that's usually part of DevOps. Containerization with Docker and Kubernetes and your environment, that's all DevOps stuff. CI/CD stands for continuous integration and continuous deployment, and this is using tools so that you can push code to a repository and it will automatically deploy to your server. And there's tools like Travis CI, Circle CI, Terraform is what we call infrastructure as code, or IOC. You can specify the state of your infrastructure and then automate it or automate the process of managing resources. And this goes way beyond my scope of knowledge. This is just from my own research. Now, a lot of these tasks include positions of their own. So a DevOps engineer is a specific role, but as a software developer, you may need to kind of peek into this world a little bit. It really depends on where you work. So just something to take note of. Now, the web is getting much more interactive, and animation is a big part of that. So there's a lot of libraries that you can use to create animations. So I'm just going to very quickly go over some of the big ones. So GSAP is a JavaScript animation library that's used by a lot of big companies. It's widely used for creating really complex animations. You have Anime.js is a lightweight JavaScript animation library that offers simple and flexible animations with a focus on readability. It supports CSS properties, transforms, and more. And I do have a crash course on Anime. And then Velocity.js is known for its speed and performance. It can be used for animating CSS, SVG, and DOM elements. It has a very simple syntax and good documentation. And then React Spring is a physics-based animation library for React. It provides a sample API for creating interactive animations in React. There's other libraries, animation libraries that you can use for React and other specific frameworks as well. 3JS is a really, really cool JavaScript library for creating 3D graphics and animations. It provides a high-level API for WebGL, which is a JavaScript API for rendering interactive 2D and 3D graphics with any compatible browser. So I've seen some really cool stuff built with 3JS. In fact, if you go to the website, you'll see a bunch of really cool examples that you can look at and interact with. And then Typed.js, I figured I'd throw that in there because it's a cool little library for creating text-based animations. So things like typewriter effects and text transitions. So it's a good choice for adding dynamic text content. So VR and AR, which is virtual reality and augmented reality, are getting bigger every year, and I think it's only a matter of time until they're common in the world of web development, because we're going to have websites that are virtual. We're going to have websites that have augmented reality, which is basically a mix of virtual and the real world. So if you want to start to get into that now, you can. It's definitely not something you have to by any means, but if you want to just mess around, there's some technologies like A-Frame, which is a web framework for building virtual reality experiences. It's built on top of HTML, and it's very easy to use. You can also use React 360, Viro React. There's some other frameworks as well that allow you to build virtual reality experiences in React. And then AR.js is an efficient and lightweight JavaScript library for creating augmented reality experiences on the web, and it enables marker-based AR directly from the browser. And even libraries like 3JS allow developers to create 3D graphics and animations that are often used in combination with VR and AR frameworks. Okay, so lastly we have Web3, which is a bit tricky. There's so many different things that fall under the Web3 umbrella. It's a term that's used to describe the future of the web. There's also many different opinions on it. Some people will say that it's the future of information and communication and finance, and some say it's a campaign for marketing NFTs. Honestly, I don't like speaking too much on Web3 just because it's so early and it's such a broad and kind of controversial topic. Now, the blockchain, which is a huge part of Web3, has proven to be a powerful technology. It's a decentralized and secure digital ledger technology that records transactions across a network of computers. And it consists of a chain of blocks, each containing a list of transactions. And once a block is added to the chain, it becomes permanent and tamper-proof. So it enhances trust and transparency. And that alone is incredibly powerful and I think will stick around. I think learning about the blockchain and Ethereum and smart contracts is a really good idea if that interests you. So Solidity is the language that is used to write what are called smart contracts. Solidity is a bit like JavaScript. Smart contracts are self-executing contracts with the terms of the agreement between the buyer and seller being directly written into the lines of code. And I'm not going to pretend like I know a ton about it, but being some of the first people to learn about this stuff, I think could be a huge advantage for the future. So it's kind of like an investment of your time and of your learning. All right, guys, so that wraps up this year's guide. I know that this was extremely long. It's way longer than I wanted it to be, but I don't want to just go through some slides and just read the bullet points. I want to elaborate and just kind of let you know what I know about each part, each section of this guide. So hopefully you learn something from it. The timestamps are in the description if you want to go back and look at a certain section. Again, I have the page on my website that has a guide of my content, including YouTube videos and courses that kind of coincide with the topics in this presentation. So thanks so much, guys. If you watched it till the very end, I really, really appreciate that. That's awesome. If you could like the video, I'd appreciate it because this is basically my biggest video of the year every year. So thanks for watching, and I will see you next time.